join this periodic session.
Sir, live stream is not yet started.
I think it started. I saw the message.
There is
started.
waiting. On YouTube, it is waiting.
On YouTube, it would be started. No problem. Just join this session, and I would be solving on a PDF all the things.
Sir, I think the main problem is for me to make the matrix. To figure out the
problem.
matrix.
Yes, sir.
Okay.
How matrix
No
is
problem.
prepared from pseudocode?
Just a minute. Fine. So, can one of you please check that whether you can browse through all the slides from 1 to 5? Just check that.
Sir, I couldn't find an arrow to browse.
Yes, sir, same here.
So, what are you currently seeing? Problem 1, right?
Yes, sir, problem
Yes,
one.
sir,
only.
problem 1.
And now?
Now the
Blank screen.
context message.
Context.
Wait. Okay, anyways, what I thought that wouldn't be possible. Please concentrate on the screen only. Okay, the one I'm currently doing. And okay, so as we have told that we would discuss, okay, Vishwajit, you want to say something?
Sir, you said that you can ask any questions, sir. So, sir, actually, problem with my dashboard, sir. In my dashboard, sir, it is only week 1 assignment, graded assignment marks is showing, sir. But inside the course dashboard, all the marks of the graded assignment till week 8 is showing, sir.
Some problems with dashboard might happen. So when I told any question, I meant technical, but no problem. I think you can write to support. Right?
I have already written, sir, many times I have written. They said that we will rectify it. They reply, we will rectify it. But after that, there will no rectification in from their side, sir. So that's why I have to
Yes.
discuss it in the class, sir.
Okay, so just message your roll number in the
if
chat.
possible, you can convey this message to them. I mean, support team, sir.
Oh, yeah,
Because
just-
otherwise, sir, I will not able to attend the final exam because in my graded assignment it is showing 20 marks. So they have divided. I believe they have divided first week assignment 100 marks into 5 week. So total my score is showing 20 marks. So if it will be continuing, then I will not able to appear for the final examination.
Got it.
In that,
Just-
sir, in that way, I couldn't get any average in my dashboard.
Okay, I know that there are some problems going on with dashboard. They told it would be rectified, but I'm not sure when and how. But okay, so how should we go with it?
I have written to this problem to support team, sir. Even I called them also, but nobody's pick my call. But even though I have written a mail to them, but they replied that we will do the rectification. Please check it. Then after 2 days, I check all of the time, but it was not showing anything. Improvement. The 20 marks,
fine.
it is showing 20 marks, red color marks and showing. So if it will be continuing like that, I will not able to appear in final exam, sir.
Got it. So what I would request all of you who are facing this kind of problems, just write your roll number on the chat, this Zoom chat. Okay, write all of your roll number, and I would convey the message. Okay.
Okay, sir. Thank you, sir.
But most probably, anyways, it would be solved. But let write your roll number. I would.
Sir, has the roll number been allotted? Not
I mean,
for
for those who have your roll number, write it. I don't think so. Some of you might have been again doing this course, right, for the term part. So I think those of them you are facing the problem, they can write. And others who have not their, do not have their roll number, just write your email ID, the official email ID which you are using. Okay.
Right, sir.
Sir, when we submitted our course registration after qualifier,
Now,
after that on portal it was showing that within 7 days your document will get verified and you will notified. But within 2 days that all update gone from our dashboard and no update, no email come regarding admission letter or whether your document verified or not.
yeah.
Nothing.
So I don't know anything about those things. So
Sir, but it
we
is
have-
more than 7. I think it is second week, sir. I write email, they said, okay, we are going, but nothing happened, sir, till now.
Okay, so yeah, again, what I can do is I can again convey the same message on my side, but the solution for that. Okay, anyways, just write your roll number or email ID in the chat. You would
Sir, no roll number we get yet.
write the email ID, na? Whatever email ID you are using.
Yes, sir. I've messaged them, but
Okay, got
they
it. So
said
just
that-
write in the chat. I would convey. Okay, let us see. Fine. Okay, so now let's start with the session. And so one of you asked what is a clique. No, clique is basically, by the way, in maths you all have done the graph part. Have you all done it?
Yes.
Sir, which graph in the
The
maths?
concept
Because
of graph. I mean, the graph means not the
Matrix?
graph like not like
notes.
something. Yeah, normal. In computer science, we actually in mathematics, whatever you do, we have graphs like this, right? Some graph like this. So let's say there's a parabola or something like that. Whatever.
Yes.
So yeah, but in computer science, we have another notion of graphs, and those graphs are basically represented by nodes and edges. So that concept of graph I'm talking about, right? So let's say there are like this. These are the nodes. Okay, and then we connect the nodes with some edges like that. Yes. So these are called a graph. G would be represented by a vertex set and an edge set. You all know sets, right? So V and E would be the vertex set and edge set. So V is all the vertices. So let's say this is A vertex, B vertex, C vertex, D vertex, C vertex. So V would be a set which is A.
Yes, sir. On mathematics, there is a chapter, sir.
Yeah, so all of you have done that. I mean,
No, sir, I dropped the maths this time.
Sir, that is in 10th week maths. We have just received.
okay, fine, no problem. And we'll just discuss the basics. Otherwise, it would be difficult to discuss this week, and that's why most of you are facing difficulties. What I suppose. See, so before moving into the coding,
Sir, one question, sir. Sir,
yeah.
actually, I was doing mathematics and statistics, and I saw in calendar that CT will be today will be stats and maths class solve with us, and that's why I did not do week 9 till now. And after today's class, I was decided to do week 9 of computational thinking. So could I continue this class or?
Yeah. See, I would be discussing from scratch as much as possible, but
Sir, graph theory I have studied in mathematics, sir.
no, that should be enough. Even if you do not know, I am just discussing that. This much should be enough. Whatever I am discussing.
Okay, sir. All question will be not much difficult to grasp, right, sir?
No, just that should be fine. We are not dealing with a lot more intricacies of graph theory over here. So just discuss the intuition behind it that I would discuss and then move to the problems. So ask
Okay,
your
sir.
doubts at every level. That's what I'm asking. That's what I'm saying. I mean technical doubts, whatever I'm discussing. So in computer science, in mathematics, as I just discussed, that we have graphs, not in mathematics, in general science. What do we call a graph? Whenever we say a graph, we mean something like this that will have a y-axis and x-axis. See, for 2D graph, there can be 3D or ND graphs as well. But anyways, so for a normal 2D graph, let's say we have the y-axis like this, okay, and we have the x-axis like this, and both of these axes would represent something, some parameter, some value, right, some property, and according to the value of x corresponding to a y or y corresponding to x, we would actually draw the point. So let's say for x equal to some value x1, y is equal to y1, and that x1, y1 is this point, and then x2, y2 is somewhere here, x3, y3 is somewhere here. Likewise, we would have multiple points. So when we have all these points, we kind of make it continuous, and then we draw a joining line like this, and we say that okay, this is a graph, okay, of the or a plot of the points, etc. So this was our notion of what do we mean by a graph in mathematics or in general sciences. But in computer science specifically, we are actually now this part of this has overlap on maths as well. But anyways, mostly in computer science field, we actually come up with another notion of what we call graphs. These are a totally different thing, okay? And this is the one that I've discussed. So we would have some vertex set and one. Give me a minute, just a second.
Bhaskar sir,
Yeah.
I have shared my email ID, sir.
Sure. Yeah, so we would have some these kind of, let's say, vertices or nodes, right? Each of these circles, they are nodes, right? And these nodes or vertices are there, and we call them the vertex set of the graph. This is the whole graph G, okay? And we call them vertex set of a graph. So a graph would be represented by a vertex set and an edge set. So you see that V equal to A, B, C, D, E, all the nodes, and E equal to E1, E2, E3, E4, which are all the edges connecting these two nodes. So what is an edge? An edge is a connection or a line between any two vertices or two nodes. Fine. So this is what we call a graph, basically. Now, this was the structural definition. What is the intuition behind this and why we came up with something like that? As of now,
Sir,
we have learned.
can vertices be empty? Can vertices be empty set? Then that set is also graph.
Sorry, vertices can be.
If vertices is empty set.
Empty set, okay. Yeah. So trivially, it's a graph. You can see. So let's say if you have G equal to V and E, and V is empty. So what you mean is something like this, empty.
No,
But
no,
then
no, no, sir. What I'm saying, in graph, there are set of vertices and set of edges, right, sir?
Correct, correct.
But in somewhere when I studied discrete mathematics, Kenneth and Rosen,
Kenneth Rosen, yeah.
they are written that set of non-empty. In edges, there can be empty, non-empty, but in vertices, they mentioned that non-empty. But when I studied for somewhere else, some teachers said that some authors say it is empty, it can be empty set vertices, and it may not be empty set. Some author prefer, but some author not prefer.
Okay, okay. So yeah, I'm telling that. See, that's what I was saying. So if it is empty set, what is V? This was V, right? Now I'm writing V as an empty set. There are no values within it. Okay, so that's what I was telling. It is blank. Yeah. So G is V and E, right? The tuple of V and E. So this is my first V, and second set would be my E. But the point is, if you do not have any vertices in the graph, right? So let's say this is my G dash graph. Let's say this is G dash. So this is my G dash graph, and there are no vertices. I'm not drawing anything. No vertices or nodes are there. So if there are no vertices in a graph, that means there would not be any edges in the graph as well, because the definition of an edge is it connects to vertices. So if there is no vertices, there is no question of edges. So ultimately, if you keep your first set of V would blank, then obviously it implicitly keeps your second set as blank. So your both V and E would be blank, and that is trivial. I mean, it's a blank thing. So that is there is no existence of anything. So that's why we would not call that a graph. That is trivial. Now, if some author prefers that, then that is some, I don't know, maybe some convention. But
so in this course, we will not prefer.
We would not prefer that. Now, as we said that the book Kenneth Rosen states, and that is actually the most conventional definition, that you can have the edge set as empty. Why? Because let me just show you. If I do not put the edges, let's say this is my G dash. I have, let's say this, and let's say this. Okay, now this is my A, B, and C. There are three vertices in the graph. Accordingly, my vertex set would be A, B, and C. But my edge set would be empty. I do not have, I'm not made any connection between. Okay, but three vertices are there, but they are not connected by any edge. There is no edge between them. So
Null
this is
graph.
a graph. Yeah. So this is a graph. So now some conventions are there. Some authors prefer some particular definition for something, but in at least this is very nice for us. In programming, we do not go for these theoretical extremities or theoretical, what should I say, these problems or debates. Our main interpretation, our main use of the graphs is where it is connected and where we are actually doing some important stuff with it. So do not focus on the definition and those extremities. Okay, just understand the concept as of now. In this course, when we mean a graph, it means there would be some vertices and there would be some edges. Okay, and they are being connected in a specific pattern. Now we will also discuss disconnected graph and all those things. But as of now, I would come to all of this. Just wait for a minute. So okay. So what is a graph? Then graph is a set of vertices and edges which are connected or maybe disconnected by edges, and they represent a physical concept. Now this part is very important that I was trying to address, that why do we come up with something, some structure like this where some edges and vertices are there which are being connected, what is the intuition and what is the motivation? The thing is, each of the vertices or nodes in a graph, right, vertices or nodes, same thing, they represent some particular entity or let's say some particular behavior or property. Okay, so you can represent each of these vertices by I'm sorry, you can use each of these vertices to represent some specific behavior, property or any element. And the edges which should be between any two vertex, right? The edge connecting any two vertex represents the relationship or dependence between those two vertices. Now, if I give you an example, your Facebook or any other social media, so that's one of the most common example of a very large graph. So you, as a user ID, you would what Facebook's internal system would do, it would allocate or it would see you as a single node. So this is your Facebook user ID, and then this is your friend's Facebook user ID. This is your parents' Facebook user ID, and this is a person, someone who is totally unrelated to you, his user ID. Fine. And this is someone else's user ID who is related to this person. So these two persons are related or they are friends. Related means they are friends on Facebook. So I would add an edge between them. Okay, so this represents that this person, that A comma B, these two nodes are friends of each other. And let's say this is you, so C, D and E. Now C and D are friends together, so they would be joined together. C and E are also friends together because E is, let's say, your father. Okay, so C, D, E, A, B, C, D, E. These five nodes are connected in this manner. So every edge represents whether you are friends on Facebook, and every node or vertex represents a particular user ID on Facebook. Now this whole structure, right? This whole structure is, you can represent it as a graph, and you can say this is a graph. Now your question would be that these two parts, this part is a connected one and this part is a connected one, but we have no edges between these two separate parts, right? These two separate parts are not connected. Now those graphs which are not connected, but they have some, I mean, they might be disconnected. They have some disconnected parts between them. These kind of graphs we call as disconnected graphs. Okay, so you can even have a single vertex over there which is not connected to anyone. Like you have just opened a new account on Facebook and you have not accepted or sent anyone any friend request. So you are a single user ID who does not have any edge connected to anyone else. So this is also a graph. So because you see, right, the definition is it's a set of vertex and edges. So obviously I can represent this whole thing as a set of vertex and edges. Okay, so yeah, so all these are graphs. So it might be a single connected part, right? This something like that. It's all of the vertices are connected. It might be a graph like this where some vertices are connected by edges and some vertices are left alone. Okay, something like that. So any of these structure where you have set of vertices and edges, they are called graphs. And the intuition or motivation behind them is each edge represents a relationship or dependence between the two vertices that it is connecting. Okay, you can again represent another example. Let's say each of these nodes represents a house in the city, and let's say each of the vertices represent whether there is a path or whether there is a street between those two houses or not. Okay, and then you can draw a graph like that, depending upon the, I mean, yeah, on your city's layout. So yeah, so that is the motivation for graphs. We represent some physical concept using the vertices, and then we use the edges to represent the dependence or relation between those sets of vertices. And then once we do that, we are able to apply some techniques on these graphs, and those techniques you would be learning in your graph theory course, I mean, sorry, in the mathematics course, that what are the mathematical techniques you can apply. So, and then we would also discuss them as a part of other course in your next level, your diploma level, the PDSA course. So then you would actually can apply those concepts on graph in order to gain some useful insights on very intricate topics on the graph. Right, you apply those learnings on once you represent the physical concept. Right, now I discussed that this Facebook thing. I discussed another whether there is a house and connection between them using lanes. There can be any possible way you can represent these vertices and edges. And once you do that, once you represent the physical concept into a form of graph, you can then apply some techniques on them, right? And then you can draw useful insights from them, right? Which would be very difficult, you know, if you would have tried directly applying them on the data. But once you convert it in the form of a graph, then you would be able to gain some useful insights by performing some specific operations. So that is the whole story behind the origin of using graphs in this computational sciences. Now coming to the topic that we will be learning in this course, that is, at first you should be aware of what are basic graphs and why they are used, the one which I just discussed. And then now we would learn that how we can represent graphs in programming, right? So we know that in mathematics or in general term, theoretical term, they are nothing but a set of vertices and edges. But now how do I represent them in the code that I'm going to write, right? So that representation we would now discuss, and then we would again go through the other parts and other questions. Now, one more thing that someone asked, that what is a clique, right? What is a clique in a graph? So you know, graph is a connection of set of vertices and edges. And let's say I have a graph like this. Fine. Just assume that we have a graph like this. Okay. And A, B, C, D, E is my vertex set, and all these edges, actually, if I name the edge E1, E2, E3, whatever. Okay, so my vertex set would be and my edge set would be E1 dot 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 up to E8. Fine. So this is a graph. Now, our definition of a clique is your clique is it can be a subpart of the graph, or you can, that's why we call it a subgraph, right? It can be a part inside the graph where all of the vertices inside that part are connected among themselves. So what do I mean by that? In this graph, consider the graph ABCDE. You can see that if I consider the whole graph, this D vertex is connected with E and it is connected with C by edges E3 and E2. But D vertex is not connected with B and it is also not connected with A. See, when I say connected, I mean by a direct edge, not by a path from D to E then E to E. Okay, not that. What I mean is by direct edges. So D is directly connected with E using E4 edge, and D is directly connected to C using E3 edge, but D is not connected to B, and D is also not connected to A. Okay, so that's why. So just keep that thing in mind. Now let's
Sir?
someone want yeah.
Sir, in a clique, the edges should be the both way, or it can be single way.
Yeah, so that depends on the definition of directed and undirected graph, but generally we discuss clique with undirected graph.
Undirected,
So yeah. So it's undirected graph. So if it is
That means
undirected,
both way, right, sir?
yeah, it is then both.
Okay.
Okay.
And sir, whenever question come, we will always assume that the graph is undirected, right? Graph
Yeah,
is
otherwise,
undirected.
correct. Otherwise, it would be mentioned in the question that it is directed. Okay, would be mentioned in the question. Now, okay, so let's come back. Now let's see for the vertices E, right? Vertex E, sorry. So if you see E is connected to A, okay, E is connected to B, E is also connected to C, and E is also connected to D. So all the vertices other than AB, other than itself, right? All the vertices other than itself, E is connected with all of them. Same thing you can see for A as well. A is, but there is a little bit difference with A, that A is connected to B, C, and E, but A is not connected to D. Accordingly, B is also connected to A, E, and C, but B is not connected to D. So which vertex A was not connected with? So not connected is D.
D is not connected with A.
Correct. And obviously not connected for B is again D. Not connected for C is there anything with which C is not connected?
No, sir.
No,
sir.
sir.
No, sir. C is connected to every elements, nodes,
So not connected for D is
A and B.
A and B.
And this one not connected is
E is also
null.
to every
Null.
vertices.
Okay, great. So now we have actually seen that all the non-connected vertices corresponding to every vertex. Now, if you observe that, if you consider the vertex, the part of the graph, I said that what is a clique? Clique is basically a sub part or a sub graph, right? We can call it a sub graph or a sub part of a graph, in which all the involved vertices are connected among themselves, right? So what I mean by that is, if you consider the graph, the sub part ABCE, this part, just consider this part ABCE. What do you see? A is connected with all the parts within ABCE. If you see B is connected with all of them, ABCE. E is also connected with all of them. So basically all the four vertices are connected with all other three vertices. Right? Only D was making a problem. D was the one that was not connected. But here, once I do not consider the D part and I only consider this sub part, right? Only this sub part I consider of the graph. Then what I can say is they are connected in all possible ways among themselves. Okay, so this is what we call it.
Clique
This is
needs
clique.
to be necessary proper subset.
Yeah, you can say
It can be graph, sir. No. I am actually saying if there is complete graph.
Yeah.
Can we say that whole graph is clique?
Again, definition. I'm not sure about how it is actually. So if you consider that subset.
Means in mathematics set there are subset and proper subset.
I understand, but again, see, these things are quite again going to the definition part of it. Just check any standard, just check any program or any standard textbook. Like in these subjects in CT or in any of the programming subjects, we do not consider those theoretical definition intricacies. Just check. I'm not sure about what is the convention. Okay. So whether by definition, clique is a sub part only, subgraph only. So. But every subset is again itself, every set is itself a subset of itself. So again, that is also definition. So I'm not sure about that. Just check what the general definition is. But conceptually, clique means a part of a graph right? Which is basically like a complete subpart of that graph. It is a complete graph which is a subpart. So yeah, check once. Okay, I'm not sure about that. So we should tell it or not, but particularly to CT, you would not require any of these conceptual theoretical problems. Okay, so this is a clique. Now, what is the size of the clique? Size of the graph was how many vertex? 5 vertex, right? Size of the clique is that we got. Size of the clique is 4.
Yes, sir. I searched on internet. There is a one website which says
I
actually
do
it
not
is
see any website. Please check
complete
any
graph
standard textbook.
math.mit.edu, where it is written a complete graph is often called a clique.
Okay, fine. But still prefer any standard text. Just check Kenneth Rosen. Okay. Fine. So this was the definition and what do we mean by clique. One more point is hops. Okay, hops is something the general term like in this context when you see the lectures sir has discussed on multiple hops, how can you reach one station to the trains example. Again in week 10 you would see that more extensively. But hops is nothing but a jump. So when you jump from one of the vertex to another vertex, right? So that we call a hop. So basically you are moving from one edge to another. If there is an edge between the vertices, so let's say there is an edge E4 between vertex C and D, and there is an edge E5 between vertex A and E. So I ask you in how many possible hops or minimum how many possible jumps or hops you can reach from D to A. Right, so one possible condition can be you can jump from D to, let me use another color. You can jump from let's say D to C, one hop, right? One jump you made, then from C to A using this edge, right? So that can be 2 hops. Another can be you can go from C, then come from C to E, then come from E to A. So there can be multiple paths. So every jump that we are making from one vertex to another, using an edge connecting them, that is basically a hop or a jump. Okay, or you can take this jump as well, one, then one, two. So if the question is minimum, then you have to take whether it is the minimum path, right? Now there can be multiple minimum paths, using minimum number of hops. So you have to check that. Fine.
Sir, clique is a set of vertices or clique is a graph, sir. Means set of vertices and edges.
So, clique means it's connected, right? So it should be your set of vertices and edges.
Okay, means clique is a graph, sir, right?
Yeah.
So if we consider just 3 edges like C, D, and D, and it can also form a clique. And similarly, there are many triangles in this graph also.
Correct. In fact, CD and E is a clique.
Okay.
CD and E itself, it's actually a clique. So it's a clique in itself, a green colored clique.
So it is just like a cycle that we study in directed graph.
Yeah, it is cycle obviously. See,
sir, in single word we can say not cycle. I think in single word everyone is friend
connected.
of everyone.
Not friend. I mean, when you are generalizing it, you cannot say friend. That's what I said. All the involved vertices are connected with all other vertices. That's the definition. Okay. So if you whatever number of vertices you consider, they are connected with all others in that particular subpart or subgraph. So if I consider this green colored subpart, how many vertices are there? E, C, and D. Now E, C, and D should be connected with all the parts in this green region. All the vertices in this green region. That's the definition of a clique. Okay. So in this yellow region, how many vertices are there? 4 vertices: E, C, B, and A. Now within this yellow region, among E, B, C, and A, they should be connected they should be connected with all others. That's the definition.
Means in one hox we can move from one vertices to any other vertices.
Yeah. Correct. In one hop, you can move from one vertex to any other vertex inside that part. And that part is itself we call the clique.
Means we can jump from D to B to reach A. Can we jump from D to B to reach A?
D to B, how can you jump? There are no edges between D and B, right?
Starting point D and ending A, so D to A, direct jump. That does not exist. That's why that is not under clique, right?
Means hop can also means only hop is only exist
Hop
if
means
there
only edges. Yeah, if there is an edge. Okay, one hop means you are traveling one edge. So if there is an edge, you can use this as to travel over here. So that is one hop.
means hop is permissible only if there is an edge.
Yeah, just remove the word hops by
So
jump, replace jump and hop same, right,
yeah,
sir?
Okay.
yeah. But it is a little bit difference is there. If you see, when I say jump, right? One hop means you are using this vertex, but that means the answer should be in one hop. In one hop, you can reach from D to A. Now the thing is, it is a hop, right? So you make a jump and then you go over it. So just skipping this vertex E is basically
Sir,
what we
D
call a
to
hop.
A, sir. How, sir? One hop, no, sir.
Yeah, that's what I'm saying. One use if there is an edge, then only you can go from here to here. That is fine. But then how many jumps you are making? Only one vertex you are skipping and then going over there, right? D and A were not directly connected. So you used E in order to reach A. So in between D and A, only one vertex you skipped, and that is your hop. Obviously, in order to reach E, you had to use an edge. If there would not have been any edge between D and E, you could not make a jump, right? You cannot say, what I mean is, let's say there were no edges over there, like this. Then I cannot say you can reach A by using D to E and E to A, because you do not have any edge between them. Getting the point, if there are no edges, you cannot go from D to E. So there is no question of hop. Hop
Okay,
will
sir.
only come when there is an edge, so I connect them. Okay, now I can do. And then I tell that how many vertices am I skipping between my source and my final destination. That is basically one jump that you are making.
Okay, sir, got it.
So
And
this
Edge
is
is
the
like a route. Without that, you cannot go from one vertex to other.
that's the
sir,
main thing.
what is the meaning of length of click?
Length of click means basically how many vertices are there inside the click.
Okay, sir.
So like wrote over here, right? 4. I mean for this one it is 4, for the yellow one.
Count of vertex.
Yeah. And for the click 2, let's say it is click 1. Click 2 it is 3. You can see that this is also click, right? We discussed. This part is also.
Sir, only a two vertex can be also a click A and A.
Only if you consider any two vertex now, by definition they form a click, but again it is trivial.
And one vertex?
No, I mean there are no edges. There is no question of again these are trivial. So one might say it, other might say no. Fine, but from computational perspective, from coding perspective, the concept of clicks only comes with minimum 3 vertices when all of them are connected together. Okay. See, because if you consider these two vertices, then they have already been connected using an edge, and that is the definition of edge only. Why do you need a separate definition for them? I am speaking in terms of computational programming perspective. Okay. So if you have an edge, then that's it. You have a name for them. You do not need to again give a new name to a new concept. Only the concept of click comes in from perspective of programming or from perspective of this subject at least. That when you have these 3 vertices, okay, and all of them are connected among themselves.
Yes, sir.
Fine. So, but can someone now answer that in the graph given above that I have drawn over there? In how many hops can you reach, minimum number of hops can you reach from, let's say, B to D, maybe? Oh, no, B to D, okay, let me just delete some of those, otherwise.
So B to D means Bombay to Delhi. B to D.
Yeah, just a minute.
Two edges,
So
sir.
two.
Two jump.
Minimum 2.
B, C, D.
So
Or
that
B,
could be
E,
any.
D.
Wait,
B,
wait,
C,
wait.
D or B, E, D, sir.
Hmm.
This
Yeah,
is
now
the shortest
I'm
path.
changing the question. I'm telling that in how many hops.
So draw one graph, sir. Draw
Wait,
other
wait.
graph.
No, on this graph only we could do. In how many hops can you go from D to A?
3, sir.
Sir, are you asking maximum or minimum?
Minimum.
So
So
3.
Can you tell the path?
DCBA or DCEA.
ECE, yes.
Two paths
So
are
the
there, sir.
path are D, C, E, A or B, C,
Yeah.
E. Okay, fine. Okay, great. So now
Sir,
let's come.
sir, in path, vertices and edges cannot be repeated, right? So, vertices can also be not repeated.
Yeah, you cannot repeat the vertex, otherwise it would form a cycle. I mean, if you repeat edge and then come to a same vertex, it would form a cycle. It cannot be repeated.
Sir,
Fine. So you would learn about these definitions and all those things in much detail in your graph theory. Yeah, someone wants to ask.
sir, in a graph, just go above one page. Question related to cliques, sir. Just here we can say B, C, E, like B
Is
to
a
C,
clique.
E to E, and E to B is a clique.
DCE is a clique.
DC,
B. This is a clique.
yeah, BCE is a clique, and BEA is also a clique.
B is also a clique.
Okay, if I suppose if I draw a vertex from A to C, then can I say ABC is a clique?
If you draw a edge, right, not vertex.
Yeah, sorry, edge from A to C.
Yeah, BSC is a clique again, and obviously BSC is a clique.
Yes, sir. Come again.
Yeah, BSC would be a clique first of all. Okay, this would be a clique. So ABC is a clique. All the triangles BCE is a clique. ABC is a clique. But now since you have drawn an edge from A to C, you see that ABCE, all of them again a clique. This whole four. I mean the whole four vertex clique. Now the question might come that what is the size of the maximum clique in your graph? So we can say that okay, the maximum size of the clique is 4. But again, obviously, see the thing is, if you have a clique whose size is 4, that is, there are 4 vertices involved. That implicitly means you would obviously have cliques of size 3, because 4 size clique means what? All 4 vertices are connected among themselves. So if all 4 vertices are connected among themselves, that means the 3 vertices within those 4 vertices, they would again implicitly be connected among themselves. So a clique of 4 size implicitly means inside them you would have clique of 3 size.
Okay,
Getting the point?
Yes, sir. Yes.
Sir, in the path DCEA, there are the hops is 2, right? Number of hops.
Yeah, number of hops is 2. Because sorry, going. Can you mute?
One.
Yeah, so how many vertices are you skipping? So that is your basically hop. Okay, so number of vertices that you are skipping, that is a jump. I mean, hopping means you are jumping, right?
Sir,
So you
hop
use
will define when path is defined, right, sir? Without path, on defining click hop will not define.
Exactly. Unless and until you have a proper path, that means you cannot reach this destination from the source. So that's what I was telling at that point. When you have a proper path, then you can go for hops. And hops means how many intermediaries are there. So how many intermediate stops you have to make, that is basically your number of hops. So in order to reach from D to A, you have to go from D to C, then C to E and E to A. So in the reaching from D source to your destination A, you have 2 intermediates C and E. So that means you have to hop, you have to jump for 2 times. You have to jump C and you have to jump E. So those are your rules.
So, sir, if you want to
2
count
hop
the
or
hop,
3 hops, sir, 2 hop or 3 hops, sir?
2 hops. You are jumping 2 times, right?
D to C.
Excuse me, sir,
C
from
to
D.
E.
Yeah.
Sure, it should
Yeah,
be 3. So D to C, C to E, and then E to A. It should be 3, right?
Yeah, but how many intermediaries are there? That's what I'm saying.
Intermediates are 2, C and E, but hops will be 3, right?
No, see the definition of hop, if you go like that, so if you see connections, right? If you see how many connections are there. Now again, in the problem, are you telling in terms of any specific problem statements? Then if you go in terms of problem statement, it may say that how many intermediates are there. That is one definition of hop. Or if you say that what is the length, then you can tell number of edges.
So,
Okay, so
if they are asking hops, meaning we have to find how many intermediate vertices are
vertex.
there.
Yeah.
Okay,
So,
and
sir,
if they are
Hop is number of intermediate vertex in a path.
okay, intermediate
Right,
vertex.
sir?
Yeah, how many jumps? If you go from C to D, that is a path connecting between them. But that is not a, I mean, you're not jumping anything. You're just using that, right? So how many jumps do you make? That is your hop.
so then terminal nodes should be counted or not?
No. Terminal node is not a jump, right? That is your destination. So
Okay. Okay.
Okay, but anyways, if it is not mentioned specifically, then you consider the intermediate. But if it is mentioned specifically that how many, I mean, there is a definition for the hops given specifically in the question, then you can follow that. Otherwise, you consider the intermediate. Okay. Fine. Okay. Now, graph, click, hops, and all these things. Okay. Now let's come to the questions. Fine. So we would now discuss, let's say, like I was telling, that graphs are basically used for representing some physical concept in the form of those structures that we just saw, set of edges and vertices, and then we would do some task on them to get some insights. Now, if you see, this is a I mean a table, right? Having some data, sequence number is there and name is there corresponding to every person, gender, date of birth, and the city. Right? This is a simple table or data, and then we would try to represent this in the form of a graph. But we have discussed the basic concepts of graph, but we have not yet seen how to represent them in, I mean, in the pseudocode, or let's say in programming, how to represent them. So graphs actually in programming, they can be represented in multiple ways, but just a second. But here in our course, we would mostly prefer graph as a set of, there would be two possible representation. One would be first would be a nested dictionary. And the second would be a matrix. Okay, you can represent them using both of these techniques. Now, what do we mean by a nested? So how many, you are clear with the dictionary concept, right? Because it was previously there. So you should be okay with that.
Yes, sir. Dictionary we have read.
Okay. So nested dictionary, what is the nested dictionary? So what is a dictionary, by the way? A key value pair, right? You would have some
value is dictionary, sir.
Yeah. Value, and you would have multiple such key value pairs. This is nothing but a dictionary. Can this value, what can you tell about this value? It can be a number, right? It can be a string.
Any data type.
Any data
It can
type,
be
right?
list, it can be dictionary.
Very good. It can be list, it can be dictionary. So that's the point. This value can itself be a dictionary again. So if I write this key and then value, and value can itself be a dictionary, then this is nothing but a nested dictionary. That's what we call a nested dictionary structure. Now, if I come to the problem's data and I write something like this. Okay, what is the, let's say, dictionary key I give? Okay, and assume that I am using the key to be this sequence number field. So 0 is my first key. And then I would have a dictionary of the data which are there corresponding to 0. But I am not writing all the data. Let us write name and city. Okay, so name is Ganesh and let's say city is Road. Fine. Comma. Index. The next key is 1. And then again I am sorry, sir. One mistake I did.
So the name colon Bhubanesh and
Sorry,
I think
yeah,
city
you are
colon
writing
Indore.
list.
yeah. I missed that. You would have name and you can have under name, you would have again value Bhubanesh. Okay, whatever dot and comma. You would have, let's say, what did I do? The city, right? City. And inside city you can write P. Okay, if these are strings, you can add the quotes and all those things. I'm skipping that part. So
Sir, it's like a JSON format structure.
exactly, it's a JSON. JSON is nothing but that. Okay. So no problem, but I just assume like this for others. Key can be anything. I mean, sorry, over here the sequence number. So I would have 0, 1, and then again inside the value I would have a dictionary, and the dictionary is this the inner dictionary's key would be the field name, city, whatever, and the value would be the corresponding value of name and city. Okay, like 1 again I would have something like that, and I would continue the representation. Like for 2 again I would have a dictionary, and then it is ended.
For 2, there will be other name, gender, DOB, city, right?
Same. I mean, yeah. Here I only consider name and city, whatever. Basically the field, and then you would have the value, whatever value is there. So next one is for 1 is Harish, right? So Harish. Okay, then you can have. If I consider only name and city, so name and city. And whatever, in whichever manner you want to be. The idea is you would have this kind of nested dictionary structure. Now, this can be one representation of a graph. Okay, this can be one representation of a graph. You can have, I mean, you can represent this whole table in this format.
And
But
how
now,
matrix, sir?
yeah. So now let's come to the matrix part. So, see, this is, I mean, we just displayed that table of data that we had in this format. But in graph, actually, we have the concept of edges as well, right? This can work as vertices. So this 0 thing can represent a vertex, whatever data 1 can represent a vertex. But we also had the concept of edges, and I told you what an edge means. An edge means there is a dependence or relation between the vertices. Correct? There should be a dependence or relation between the vertices. Now this structure does not show any dependence or relation between 0 and 1, 1 or 2 or anything, any other way, right? It's just a way we represented the data given in this table.
Organize the data.
Organize the data. But the matrix form would actually help you in order to, and that's why we actually use most of the time the matrix form. This is the true form of representing the graph. True representation of graph.
Means matrix forms is more precise.
More precise. And mostly matrix form would only be used. Theoretically, we
more
say both
informative.
Of them, yeah. Theoretically, we say both of them can be used, but matrix form is mostly used. At least in this course. Now, when you actually learn PDSA course, you would see there are again other kind of representations as well. But anyways, here matrix form is the, in your diploma term, you would see another course. There we would deal in much more complex. Okay, so there we would discuss. There are other forms of representing graph as well. But anyways, in this course, we would follow the matrix form. Now, the thing in matrix form is, so what is a matrix in general mathematics? If you see, what is a matrix? A matrix is
set of column and rows.
Correct. So because some of you might not have taken the course or may not know, that's why I'm mentioning. What is a matrix? A matrix is a set of columns and rows, right? And So let's say this is your, and since we are doing in CT or in programming terms, I would start the index from 0. But in mathematics, you may start the index from 1. So you know arrays, right? We have learned about arrays or list. So you can see that this is an array or a list, whatever you want to say. This can serve this one thing. And this is again an array or a list. This is nothing but what? I have a collection of multiple lists together. So let's say I have 0, 1, 2, 3, 0, 1, 2, 3. So I have 4 rows and 4 rows and 4 columns, and they actually are making this whole structure a matrix.
So
Now
we are
yeah.
Sorry to interrupt. Sir, we are going to take only n into n matrix, right? Like it will be the same rows and columns, not different, right?
Correct. Now, why is it so? In our case, most of the questions that we would face, what are these rows and columns? In computational sciences, these rows and columns are nothing but the graphs nodes. So the rows equal to columns equal to the graphs nodes or vertices, right? So if a graph has, let's say, n vertex, obviously in both sides I must have n from 0 to all the, let's say if I have 5 vertices, then I would have 0, 1, 2, 3, 4 on both the sides. So that's why the rows, columns, they are same thing, and they are actually representing the graphs nodes or vertices. So that's why both of them would be of equal size, because they represent the same thing. Now here you can see that it represents that relation that I was talking about in a very nice manner. Why? Because in this structure we see that the node corresponding to name 1 or in number 1, whatever, that is actually associated with 0, 1, 2, 3, all of them. And whatever value I put inside these boxes, they actually indicate the relation of the node 1 with 0 itself, second node and third node. I mean the third and fourth node. Okay. So that's why these value inside these empty cells, right? They represent which part. So the rows and columns, what I mean is, let me just mention it using colors. This numbering, the rows and the columns, they represent the graphs, nodes and vertices. And the values, right? The values inside these parts, they actually indicate you the relation between the nodes and vertices.
Edges.
That's why, correct. So the values inside the matrix is nothing but the edges.
So actually 0, 1, 2, 3 are the name of vertex.
0, 1,
and
2, 3 are the
name of vertex. And it always be same, because in row 0, 1, 2, 3, then in column 0,
Obviously.
2, 3, 4 cannot be, right, sir?
No, it cannot. We are just using the same name. The main idea is, if I have a graph like this, right? It is 0, it is 1, 2, 3, right? If I have a graph structure like this, so let's see if I go ahead with this. This is my graph. Now I want to represent it in the form of a matrix. So what I do is I write 0, 1, 2, 3 over here and down as well, and then I would check the interrelation, right? I want to check what is the relation between each pair of these vertices. So in order to check for each pair of vertices, I would obviously need, if I have 4 vertices, I would need how many? For each pair, how many possible pairs can I form using 4 vertices? Normal combination. NC2, right? Correct. Actually not combination, I mean, if I consider itself as well, right? NC2 means how many way you choose. Now here I mean how many possible pairs you can consider by even considering itself as well. So that would actually consider pairs of I comma I form.
Factorial.
So that would be 4 comma 4. If you have 4 vertices, I want to check the property or the relation between all of them. So I can use 4 comma 4, right? 4 squares. So that's why 16. 4 on top, 4 on bottom, 4 rows, 4 columns, and I can get all possible pairings. right? What is the relation of 0 with 0? What is the relation of 0 with 1? What is the relation of 0 with 2? What is the relation of 0 with 3? Likewise for all other vertices. Now these inside values represent your graph, whatever you do. Okay. Now there can be two possible kinds of graph. One graph is simply the connectivity graph, right? Now what do we mean by connectivity graph? So let's say 0 and 1 are connected by an edge, but 0 and 3 is not connected by an edge. So I can use this matrix to represent this graph by putting the values. So I have an edge between 0 and 1. So I would represent that fact that I have an edge between 0 and 1 by putting a value true. You can use Boolean values true, false, that if you have an edge, you can write true. If you do not have an edge, you can write false. Or you can even use 1, 0, like whatever representation you want to use, you can use. So mostly 1, 0 is used. So if I have an edge between two vertices, I would go to that particular cell inside the matrix corresponding to those two vertices and I would write 1. That means there is an edge between them. So 0, 1. So let's take 0, right, and 1. There is 1 here. So what is the intersecting point of this row column? So for the 0th row and the first column, intersecting point is this one, right? So here I would write 1. So there is an edge between them. Accordingly, the thing is now, see, 0 and 1 are connected. I considered from 0 to 1. But what does this cell means? This cell, this one, the one on which my mouse is
1, 0.
This is also
1,
connected.
0, 1.
This would also be 1. Because anyway, this is undirected graph. So I have not given any direction over it. So when there is no direction, you have to consider both ways. It is both ways connected. So 0 to 1 and 1 to 0. But if in directed graph, I would have told you that this is the direction, then I would only have one bit from 0 to 1. That is from 0 to 1. Here I would have 1. But from 1 to 0, I would not put 1. Because 1 to 0, there are no edges.
So we have to read the data row wise always.
Correct. This is your starting point. From here you go towards this. Okay. Fine. So if I just draw, I put the values all of them. So 1, 2, 3 would be a graph. 1, 2, 3. Sorry, not graph. An edge. 1, 2, 2. 3 to 2. Now see, one important point is I have drawn one way, the other ways are missing. Right? So what would be the other way? So 1 to 2 I had, so 2 to 1 would also be there. So 2 to 1. And
3 to 1.
3 to 1.
No, but makes fewer mistakes to figure out some line that separates the plus from line.
2 to 3.
And 2 to 3. Can you see a pattern in this graph? Can you see a pattern? Pattern means you just say whatever comes to your mind. Any specific? Okay, other would be 0. Huh? Sorry. All of this would be 0.
Upper
half and symmetric
lower
about
half
main
are
diagonal.
Sir.
Yeah, symmetric about diagonal.
So,
Yeah.
like it is 1 to 1 is connected, and then 1 and 1, and then 1 and 2, 2 and 3. So I think it is forming a clique.
Actually, it is undirected. That's why direction is reverse and forward same. 0, 1, 1, 0.
Yeah, that is fine. There are actually two important points to observe over here.
And diagonal is 0, sir. No self loop.
Correct. So the main observation that I was actually trying, there can be multiple observations, but there are two main things that I want to say. That is, first of all, this undirected property that you put and one from corresponding from 1 to 2, you also have to put a 1 in the cell corresponding to 2 to 1. So this property is making us symmetric. You see that this is a symmetric kind of thing, right? This one is corresponding to this one, is a symmetric part. This one is actually corresponding to this one, and this one is corresponding to this one. Accordingly, this one is corresponding to this. So this is actually creating a symmetric pattern. right? It's like
Yes,
this,
sir.
mirror image. So if I put a mirror over here like this, you see that this is exactly the mirror image. Just put a mirror in both the halves. If we delete all this,
Sir, I think this is skew symmetric matrix, right?
sorry.
A matrix which is symmetric about main diagonal. I think skew symmetric matrix.
So the definition of skew symmetric and all those things, it's not there in our discussion. Skew symmetric would be, there would be negative terms.
Yeah.
So I'm not going into all those.
Correct.
Okay, it's just simply symmetric. So if you are saying that it is skew symmetric because the left diagonal elements are zero, that is also thing. But skew symmetric matrix would be negative. One part would be negative.
Oh,
Okay.
symmetric matrix, right?
Yeah, it's a simple symmetric matrix. So don't bother
Main
others.
diagonal will be from the right one, not the right diagonal, not the left one. Like the principal diagonal.
Principal diagonal is the left diagonal.
Yeah.
So, okay, so what doesn't matter what is principal diagonal, what is skew symmetric, symmetric, all these things I think you learn in the maths courses. Those who have taken, fine. Those who have not taken, please don't get overwhelmed. Whatever we are discussing here, that should be it from the at least the CT part.
Yes, sir. Mirror image, sir.
It's just a mirror image. So if I put the mirror on the line that I have drawn, you can see that this would exactly generate, the both halves would exactly generate the same image. Okay. So this property is only happening because you have an undirected graph. So that is one important thing. The other important point to observe over here is, as someone mentioned, that there is a clique, and even without seeing the graph, you can see the graph and obviously tell that okay, this 1, 2, 3 is forming a clique, right? A triangle, all the vertices are connected. But even without seeing the graph, you can see the matrix and check that it is forming a clique. Can you tell how you can check that? By seeing the matrix. How to find, the question is how to find the clique by, and this might not be a single step process. Just tell me how to do that.
Sir, we can easily see matrix like 2 1 and then 2 2.
Sir, I think we have to jump around that main diagonal, sir.
Yeah, just let her complete. Yeah, please complete.
1 2, sorry, yeah, 1 2 1 3 and 2 3 and then 3 2.
So let me ask you this: in which, how, if I tell you to write the steps, how you would check whether there is a clique by?
Sir, I will check. Sir, I will check the symmetry. Like, if it is how to explain? If it is like 1 to 2 and 2 to 1 is there.
Okay.
Like, and then is there any, like I can see that 1 to 3 and 3 to 1 is there, and 1 and 2 is also connected. So likewise,
the matrix is given, then we draw the graph. After that, we can find out.
Yeah, I'm talking about matrix.
Sir, I think I have a way, sir. I think it is bishop, sir. In chess, the hathi, sir, the move of bishop, 90-degree move, sir. If there is 1 1 in 90-degree move, we can move, sir, right? And if you come.
Okay, see, the thing is, see, let's say, first of all, let's address the symmetricity part. So let's say if I would not have this 3 2 was not there. So let us remove the 3 2. This one is not there, this one is not there. You would still have symmetry. Symmetry, yeah.
But sir, like there is nothing to connect like this row 2 and column 3, right? So yeah, that is 2 3. So if it is not connected, then it cannot form a clique, right?
Yeah, but
there should be.
How when you write a program, how you write that? You can see that from the graph and from the.
No, I'm not looking at the graph. I'm just looking at the matrix, and then I'm telling like looking at all the ones.
Okay. So if I tell the how to write the steps, so what you can do is you check each vertex, right? And for that vertex, check wherever you have got 1. Okay, so let's start from 0. Now it would be, actually we have a question on this only. So it would be a bit large algorithm, but let us say how it is working. So you take each vertex, start from 0. Okay, and see right hand side that what if whenever you are getting 1. So that means there is an edge between that vertex with this vertex. So 0 and 1, there is a edge, right? Now, as soon as you see that 0 and 1, there is an edge, you have to check whether I have also an edge from 1 to 0 or not. So you go and check whether there is an edge from 1 to 0. So you do that exactly. So yeah, there is an edge 1 to 0. Fine. And then again return back to the previous. Go from 0 to the next one, 0 to 2. Now 0 to 2, there is no edge. So no problem. 0 to 3, there is no edge. So no problem. Now that means there is a trivial definition. This is not a clique showing that this is just an edge. But let's take the example where it was actually a clique over here. Let's add these two values. Now let's take this example. So when you are traversing one by one on all the vertices, let's say you come on to second vertex and check. So first one is 0, then there it is 1 is there. So 2 to 1, there is an edge. So now again go and check whether 1 to 2 is an edge. Right? So obviously 1 to 2 is an edge. Then again proceed further one by one. There is 0, and there again I have 2 to 3 is an edge. So check 3 to 2 is an edge or not. So you check 3 to 2 is an 3 to 2 is an edge. Now once you have reached this, so what are the vertices that you encountered in this process? You encountered the vertices 3 and you encountered the vertex 1. These two vertices you have encountered in the process. Now you have to go and check, right, whether 3 is connected with 1 or not. Getting the point. So in order to check, when you are checking with 2, you saw that I had 1 in 2 columns. In column corresponding to 1, column corresponding to 3. That means 2 is connected to 1 and 3. If I am suspecting these two form a clique, then 2, 1 and 3 must be connected among themselves in all possible manner. Now I know that 1 and 3 I have encountered, which are connected with 2. And if it is a clique, then 3 and 1 should also be connected. So the next thing that you check is that, okay, since 2 had entry 1 corresponding to 2 vertices which are 1 and 3, so I must also check whether 1 and 3 are connected among themselves. So now just go and check whether 3, 1 or 1, 3 are 1 or not. So I go 3, 1, which is this, and it is a 1. And check 1, 3. Obviously, it's undirected graph. So even if you do not check, that is also fine. So 1, 3 is also. So basically, in order to properly find the clique, how can you write the code is traverse through a vertex, all the vertices. So let's take this vertex. Check in the row of that vertex where you are getting 1. Right? Sorry, I mean in the whole row. Yeah. So wherever you are getting 1. So let's say you get 1 in 2 or 3 of the entries. So let's take this entry. This entry I see 1 is there for 0, 1 is there for 2, 1 is there for 3. So 0, 2 and 3. These 3 vertices are connected with 1. Okay. Then again you check and you again go and check whether 0, 2 and 3 are connected among themselves or not. So you would see that 0, 2 and 3 would not be connected among themselves. 0 is not. So that would not form a clique. So 0, 1, 2, 3 is not a clique. That's why this is not a clique. Okay, then again you proceed. So when you are at 2, now you would see, okay, I have encountered 1 at 1, I have encountered 1 at 3. So now you check, since 2 is connected to 1 and 3, if I want this to be a part of clique, both 1 and 3 should again be connected among themselves. Right? So you complete the traversal of one vertex at till the end. Note down which vertices you got 1. You got the value corresponding to 1. Go to those vertices and check whether they are connected among them or not, and then you will be able. That's a more comprehensive way you can check whether there is a clique or not. Visually looking at the matrix, you can understand that there would be a symmetric matrix which would have 1 in all entry. The visual way is actually just consider a smaller matrix like this. Okay. Remove all the left diagonal elements. If all other elements are 1, it's a clique. So if I tell you an example like this, let's say so the pseudocode or the step-by-step would be, I discussed, take one vertex, check all the elements where you are getting one, go to the row corresponding to those elements and check whether you get one in those cases as well. That is the idea of writing the pseudocode. But simply if you have been given the matrix, then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Yes, yes. So let's go on. Let's say I have something like this. Okay, I'm writing arbitrarily. Okay, this is most probably we would actually, it's not symmetric what I think anyways.
So do not write 0, only 1, sir.
Sorry?
Sir, I think only 1 has significance, sir. Only
Anyway, adding 0 doesn't matter.
0
What
is
I mean,
confusing.
yeah. Anyways, so assume you have some, I mean, all the empty cells are 0. Okay, and how you can actually visually see whether there is a clique or not, I actually drew that first. I hope you already got the hint. The thing is, consider a subpart of this matrix. Okay, just consider what is a clique. A clique would have lesser number of vertices than the whole graph, right? I mean, at least in our discussion. So it would be a smaller subpart of the graph, which would be a complete graph, or that is all of the vertices among them are connected. So that means what? You consider a subpart of this matrix. If this matrix represents the whole graph, consider a smaller part, in which, let's say I consider this smaller part. Just consider the left diagonal elements, sorry, just ignore the left diagonal elements. So that is 0, 0, 0. Just ignore that. Ignore that. After ignoring them, whatever cells are left, if all of them are 1, then that is a clique. That's how you can identify whether there are cliques in a graph or not. I mean, just by seeing the matrix, visually saying. Okay,
so we have to make a square, sir.
Yeah, obviously square, because again, what is a clique? It is a smaller part of the graph. That means it would have smaller number of vertices. But if it is a smaller graph, obviously it is a graph, right? If it is a graph, again you represent graph using the same concept. Whatever number of vertices are there, you keep them in the row, and the same number of vertices you keep them in the column. So therefore, this itself represents a graph, a smaller graph. So the number of in the rows, number of vertices in the columns and number of vertices in the rows should be same. Only thing is it is lesser. So this is a clique. Okay. So find the square matrix, which is a subpart of the larger matrix. In that square matrix, if you remove the left diagonal or if you just neglect the left diagonal, if all other values are 1 other than the left diagonal, then you can say that is a clique. That is a visual inspection. Okay.
So this is forming a clique of 3.
This is forming a clique of 3 because there are 3 cells.
Okay.
In fact, if you see in our drawn example here as well, we had a clique of size 3 and we had a structure like this. To remove the left diagonal, all of them are 1.
Yes, sir.
Fine. So,
If the diagonal elements are 0 and remainings are 1, then it is said to be clique. Key point we can remember. Okay.
Correct. Correct.
Sir, one thing here.
Yeah. Oh, sorry, I forgot to mention one important part. So I told you that we can put 1 and 0 in the graphs, right? And the other form of representing graph is that is we are adding one extra layer of complexity. I will come to your question just by telling this small thing. That is, let's say Now we not only want to represent whether there is an edge between the nodes or not, but also we want to represent some extra information. Now, what do I mean by extra information? Let us say I want to represent, right? So I told you, let's say that Facebook example that we took, that each of the nodes represent a user ID, and each of the node represent a user ID, and each edge represent whether those two user IDs are friends or not. Okay, now along with that, let's say I want to represent the fact that how many mutual friends these two user IDs have. Okay, obviously mutual friends, okay, I'm not sure. Yeah, mutual friends means when you are friends, then you can have mutual friends. So if you have an edge between 1 and 0, that means 1 and 0 are friends, then only I am going for that mutual friend concept. If there is no edge between 1 and 0, that means when you are not friends, then there is no concept of mutual friends, right? So if there is no edge between two nodes of the graph, that means they are not friends, then I'm not considering the concept of mutual friend. There is
So finding mutual friend is same as the clique. Is it?
no. Clique means all connection, right? Mutual friend means it may not be that. I mean, see, the thing is, if we have to consider it as a clique, then all the mutual friends again should be mutual friends of others. Then that is not something we are telling. Getting the point? So what I mean is A's mutual friend is B, C, and D, and A and E are actually the friends we are talking about. And E is also obviously B, C, D. They are mutual, right? B, C, and D are mutual friends for A and E. What I'm telling is, this is the only information that we have. A and E are friends. A and E are friends. And B, C, D are mutual friends.
Yes.
But I'm not saying whether B and C are friends or not. I'm not saying whether C and D are friends or not. Okay. In order to have a clique of A, B, C, D, E, I must have B and C as friends as well as C and D and B and D, basically all of them. But I'm not telling that when I'm considering mutual friends. Okay, so it is not a clique. Okay, anyway, so coming back to the previous discussion, that when I want to represent the number of mutual friends as well, then I want to do that, let's say, by putting some value on the graph. So let's say 0 and 1, they have 5 mutual friends. So I would add 5 on the edge. Obviously, I'm pointing to this fact multiple times. Please observe these little points. Mutual friends should not exist unless and until both of you are friends. And that is the main point, which is actually contributing to the fact that the value on the edge, which is representing the mutual friend, right? Number of mutual friends, that value cannot exist unless and until you have the edge itself, because the edge represents the friend property. And the value of that edge would only be there when there is an edge. That means the mutual friend would only happen when there is a friend relation between the vertices and the considered. Okay, fine. So 0 to 1 there is 5, and let's say 1 and 3 have mutual friends. 1 and 2 has, let's say, 18 mutual friends, and 3 and 2, let's say, have one mutual friend only. Okay, so this is one extra added layer of information that I want to represent using the graph. Now, how can I do that? Simple. Only change we would do is now we would put the values rather than just putting 1. So 0 to 1 I have 5. So 0 to 1 I would put 5. Obviously it is undirected. So 1 to 0 would also be 5. And accordingly whatever. So 1 to 3, 1 to 3 is 2. 3 to 1 is 2. Likewise, I'm not filling the whole thing. So whatever values you have, you put them. And whatever the cells that remain empty, keep them. Okay, so let's say 0 and 3 are disconnected.
This is the kind of weighted graph you are saying?
This is a weighted graph, exactly.
Okay.
Okay, so the first was unweighted graph, this is weighted graph, and all of them are undirected as of now. But even if they are directed, only thing that you have to change in the matrix is when I am putting 0 to 5, I should not put 5 to 0. That's it. I mean, whichever direction I am getting, consider from the left to the right. Okay, so basic graph concept is clear.
Sir, if mutual friend is not there, age is there or not?
Yeah, so since, yeah, obviously, according to the concept, if there are no mutual friends, then also friendship can happen, right? If I'm using that concept. So yeah, you can have edge like that, no problem. I mean, I can have 0 as well. But in that case, I cannot put 0 in all the places of the matrix, right? Because if I say that 3, 2 are such friends that they do not have any mutual friend. So what I write here is, let's say
0.
0.
Yeah.
But if I represent this information in the graph, 3, 2, 3, 2 corresponding, here I write 0.
0.
The problem now is what was the entry in between 0, 3 or 3, 0? 3, 0 was also 0, right?
Yes.
Because there is no edge.
It
So
should
now
become something else, nil or
Correct.
something else.
Correct. So how can I differentiate between these two? That whether 0 means mutual friend 0 or there is no friendship at all.
Yes.
I cannot represent that. So in that case, simply you represent all the whenever there is no edge, right? You can represent that with some value, let's say -1 or whatever.
Okay.
Represent that with -1. So it's totally at the programmer's convenience how you want to represent it. Okay, how you want to use it.
Yeah, got it, sir.
Fine.
Sir, just like you show that problem like date of birth, E-road, CT, that table, how could I make it as a matrix?
Which one? This one, right?
Yes, this
Yeah, I
one.
want to come to that. But
Okay.
basic concepts I want to clear. Now let us come to the problem. Okay, fine. So till now, whatever we have discussed, that was enough for your concepts to do graph questions in this week, and most probably in the next week also. We would build upon these concepts, but the basics would remain same. So this is how we represent graph in our program. We would represent graph by using matrices. Okay. And yeah, so this was matrix, and how you can form a matrix is we are using this common syntax. Create matrix is a method, and inside that you would pass the argument that how many rows and how many columns. So p comma q, p and q are the p is number of rows, q is number of columns. Now we know that in our graph examples, right, when we are using matrix to represent graph, we know the number of, I mean, these rows and columns are simply the number of vertices. So they should be same. So in our graph example, or not most, all of that, all times you would have these are something like this in common. N nodes and N nodes. Okay. But in general, matrix can be used to do other computations, right? So
And how to access them?
How to access that is simply, let's say you write create matrix A. A is your name of your matrix. You can write directly like this. Let's say I comma j. This I and j are the row and column. So I means the row ID or row index properly. If I say properly, it is actually row index. And j is your column index. Right. So when I write I comma j, let's say my I is 4. 4 is not there. So I is 2 and j is, let's say, 3. Okay. So what do I mean by that? Second, I mean the row with 2 ID, so which is this one. Okay. And column with 3 ID, that is this one. So if I draw the intersection, so this is the cell that I am talking about.
Sir, it is like nested list.
Yeah, exactly. It is like nested list exactly, but the only thing is in list you had only option for, I mean, adding a single value at each listed point, right? But if I want to have multiple values at each listed point, so what I mean is corresponding to this part, only this part, right? This cell, corresponding to this cell, I want to store a group of values. So again, adding to the social media example, one user ID and 2 user ID, they are friends. So that's why obviously here I was till now I was putting some value, right? I mean the number of mutual friends I was putting over there. But I don't want to do that now. What I want to do is if there is no friendship, then this value would be -1, right? But if there is a friendship, then what I want to do is I want to store all the details for let's say some common details for 1 and 2, right? So let's say when 1 and 2 actually accepted each other's friendship request, when let's say they met together or something, some other details. So I want to keep a collection of information between about the friendship of 1 and 2. So if I make a nested list would not allow me to do that. List would only have one data at that point. But if I want to have multiple values, multiple data corresponding to this point, corresponding to 1 and 2's friendship only, right? So then I have to have some other data structure, which is my, some other way to represent the data, that is dictionary. So that's why we use nested dictionary instead of nested list. Fine. But matrix is, matrices are basically, that's what I said, matrices are kind of nested list and nested array, whatever.
Okay, sir.
Fine. Now coming to this example, now how you can create a matrix out of the data out of this data. Now I told you that in matrix, the main part was the relation, right? So these rows and columns, whatever the intersection points were, this intersection point was the cell, and this cell represented the relation between the j column and ith row. So that relation was actually getting represented in the matrix. In this example, now let us see how we can have that relation. Now this is just a data. There is no relation or nothing given over here. In order to find the matrix, I must have a relation at first. So that relation is there. Now we are talking is here actually. Sorry. So now we are talking the relation. What is the relation is, just observe this part. I will come to the code line by line, but as of now, just see this part. You see that is related method, right? Whether x and y are is related. What is x, what is y? Again, when it come from start, I would discuss. But just see what is related doing. It is checking the first of x and y, whether it is same or not, and last of x and y, whether it is same or not. Now, what is first of x and y and last of x and y? What is x and y?
DOB and gender.
Correct.
Sorry, I think it is list x and y.
Yeah, x and y are two lists, but the thing is, what is there in x and y? So if I check this line, right, you see that I have DOB and gender, these two are there in the list. So every here, the x over here and y over here, it would be of the form date of birth and gender. So first would be DOB, second, last would be gender. And what is this line doing? It is checking whether first of them is of the two entries that I received, x and y, they are same, and last is also same. So that means date of birth and gender of the entries, whether both of them are same or not. If they are same, I am returning true. If they are not same, I am returning false. Okay.
Returning true means that will indicate 1.
That would no, that would not indicate 1. Let us see what is happening when I am returning.
Okay.
So when I am returning true, where is this is related method called in this code? You see that is related, it's called where. I would come to this line by line again, but just have an overview.
Sir, when recording ith and jth of matrix.
What?
Sir, dith comma jth.
Yeah.
It is recording a cell, right?
Yeah. It is going with the keys of the dictionary. I would come to that. Just as of now, see these two lines. Okay, just see these two lines. So the relation over here I was talking about, right? In order to form a matrix, you must have a relation, and that relation would represent whether there is an edge between the two vertices or not. Now that relation is the only thing that I want to discuss at first. Then I would go line by line. So this relation is whether your date of birth and gender, both of them are same for the two vertices or not. Okay, and when I am returning true, that means is related over here would return true. So that if statement would become true, and I would come inside the if statement, right? And I would write a of ij equal to 1. So this is your 1. This is where I am putting the 1.
Relation.
1 is
Correct.
recorded.
Okay, so A is the matrix. If you see that, so A is the create matrix.
Somewhere
So
we are writing 1 in a matrix A.
In a matrix A, we are writing 1. Now, where we are writing and all those things. Now,
where the date of birth and gender are same.
Correct. So that means The relation that we were talking about is whether when the entries have same date of birth and gender. Okay, now come to the data over here, and before going to the matrix, help me draw the graph. Draw the physical graph at first. Fine. Okay, so I have many rows are there, so let's see this row. Okay, fine. So tell me which.
Here 0, 1 is connected.
Okay.
And 3, 4, 5 are connected with each other.
3, 4,
3,
5
4,
are
5
connected.
connected with each other. 3, 4, 5 must be clique.
3, 4, 5 must be a clique because female, all of them female, all of them female. So 3 is connected to 4, 3 is also connected to 5. Okay. Okay, now 0, 1 is connected. And 2 is totally separate.
Yes,
Two
sir.
is
2 is
totally
isolated.
That's great. Fine, that's it. Do we have any similarity anywhere else?
No, first of 2 is similar with
Sir,
first
we have to
of
see
0
only
and
gender
1.
and DOB, right, sir? Not city.
No, both of them, only gender and DOB. Because that's the relation we are using to draw the edges.
Yes.
Anyway, so this is complete, I think. This is the graph. Okay. So
Yes.
very important point is these edges represent this relationship, and we need to take a parameter or a property, whatever. And that property would be used to draw the edge. In the matrix, that property which decides the edge actually corresponds to a non-zero entry in the matrix. That's the whole concept. Now, obviously, if I draw a matrix for that, how would the matrix A look?
Sir, I created the matrix.
Great. So this will be something like this, and actually,
Sir, I think only half part creation will be sufficient, right?
yeah, that is another point. Okay, you can have it as, let's say here 0, 1, 2, 3, 4, 5. Okay, so this is your principal diagonal, left diagonal.
0,
And where
1.
0, 1 would be 1. 3, 4, 5
1,
would be
2, 3,
connected. Acha, now help me draw the structure. 3, 4, 5, right? So 3, 4, 5, this part. How should this part look? Just quickly we can say, right? Without thinking anything else. 0, 0, 0, without even seeing all of the parts.
Yeah, all
Rest
parts
one.
are 1.
Or else 1, sir.
Very fast. We can do that even without checking the edges, just directly. Put left one 0,
Yes.
put all other one.
Yes.
Fine. All others will
And
be 0.
here 1, 0 also be 1.
Sorry. So this is the graph that we are talking about. Now again, there are multiple things. I mean, it's a very intriguing field in graph. Computational sciences using graph, it's a very nice field. Now you see that there are a lot of entries which are empty, as someone was telling. So we actually deal with this kind of graphs in a different manner. We actually do some other, I mean, what should I say? Some operations to actually use this space, right? If I'm using a matrix, that means I have written the code already. I'm writing create matrix. When I'm writing create matrix, the space corresponding to this entries are already getting allocated, and that's why there is a usage of space, wastage of space. But this, because these entries are not using. Okay,
Space
so
allotted, but nothing is
nothing is there.
entered there.
Okay, so these kind of matrices are what we call the sparse matrix. Not required, not there in your syllabus in anything, but just discussing. So we do some interesting operations on this matrix to actually reduce the space and still have the same amount of information in them. So you would learn some of those things in the next level in the algorithms course, PDS. Okay, now let's come to the code one by one. As now you have the intuition of with this data how we drew the graph, and by seeing the graph you also know how to draw the matrix. Now let us see how the code is doing that.
Sir,
Yeah.
sir, will you continue after 8 because we have another session starting from 8.
Actually,
Whatever
that
you
is
say.
open session. That is doubt solving only.
Okay. So see, I would continue 2-3 problems. If it goes maybe half an hour, you are late also. You can see
Okay.
the recording, right?
Okay, sir.
And sir, one request from I think everyone would like that. One day extension for all graded assignment. 10 days. I think 9 at 9 there is week 9. It would be better if it is at 10th of November.
Okay, I would convey the message, but there are some other modalities involved. Let me check if it is possible. You would extend. 10th you want, right?
Yes, sir. At least one day, sir. 10.
Okay. Fine. Let me check.
Yes, sir. And actually, 20 there is quiz, and in 16 there is a week 10 assignment. So it would be better, sir. For week 9 and week 10. Week 9, sir, 10th of November.
Oh, okay, fine. Okay, now let's see the code pseudocode ones. So we have this d equal to init dictionary. So this is where the code starts. We have d equal to init dictionary. The init dictionary, what it is doing is simply creating the dictionary, right? The one first you have to, from the table you have to create dictionary. That I did initially. Remember, initially I made the dictionary, and from that dictionary you actually go for the matrix by using a relation. So let us see. While table 1 has more rows, you read the rows, and this is the dictionary's format, right? You should all be aware of this now, because text.sequence number is what? It is the key. And this whole part would be the value.
Yes.
So what I'm doing is going through all the entries of the table and then creating a dictionary of this format. Sequence number 0 with a list where first would be the date of birth and second would be gender, male, female, whatever, comma 1, like that.
So actually we have created first a nested dictionary for data.
As of now, this is not a nested dictionary. This is just a nested list. I mean, sorry, a normal dictionary with a list inside of it.
Oh, yes, sir. Yes, sir. There is list, not dictionary.
Yeah. Nested, this is not a graph, right? This is just, we are making a dictionary. We are not making a graph. Graph has nested dictionary. Okay. So I think in one lecture is there in the initial part of how you can represent graph using nested dictionary. So this is not a graph. This is not graph. This part of the code, right? This box is not graph. This is only making the dictionary. And the dictionary has is of this format. Fine. So once I make the dictionary, we return the dictionary, right? And D is my dictionary now. Now see, we told that in the graph that we drew, right? We told that sequence number were the number of the vertices. There you can see 0, 1, 2, 3, 4, 5. The vertices were the sequence number. And here in our dictionary, we had the sequence number as our key. So if I write something like this, length of is B, what does this mean corresponding to our graph? N
Count
goes to
the sequence.
Number of nodes.
Correct. N would store the number of nodes, right? After that, what do we do? Once we have the number of nodes, in order to create a matrix, we would write this line, right? And combine.
N
So we have
cross
the
N matrix.
So this is where the graph comes into play. Okay, this is your graph. Okay. So now you have brought your graph, and what does the rows of this graph represent? Rows means all the sequence number. Column also means all the sequence number. Right. Now let us see. For each I in keys of D. What is the keys of D? 0,
Sequence
1.
number.
Yeah. So keys of D means, which is 0, 1, 2, 3, 4, 5, which is nothing but your sequence numbers.
Sir, what is the meaning of, sir, what is the meaning of keys of length? Length of keys?
Keys of length? Length of keys means how many keys are there in the dictionary?
Number of element.
Number of element. Okay. Number of element means number of keys. So
Actually,
this was the
keys
dictionary.
return list, right, sir? So how many elements are there in list?
No. See the dictionary. This was the dictionary that I made. Right? This was the dictionary.
Yes, sir. But when we call
I
the
think
function
output
keys,
will be 6, sir.
we get list of keys.
Output will be 6, sir. 0, 1, 2, 3, 4, 5. The length of key. The output will be 6.
No, length of what does this part? Let us check what does this part.
This is a list.
Correct. So this is a list. 0, 1, dot, up to 5.
Okay.
Now on this, if you apply length, right? Length is applied on the
6.
whole thing.
Total 6.
So that's what is happening.
Okay. 6. Yes.
So n is 6, and then you create matrix 6, 6. So this is nothing but a matrix that we created with 1, 2, 3, 4, 5. 1, 2, 3, 4. So this matrix will be created. Fine. Okay. Now for each I in keys of D, other keys of D is a list, right? Keys of D would be this list 0, 1, 2, 3, 4, 5. So for each I means I would traverse from 0, 1, 2 like that, and then for each J in keys D again. So there is a nested loop on the same list. Both of this is operating on the same list 0, 1, 2, 3, 4, 5. Both of these loops are operating on the same list. And then I am checking if I is not equal to J. So this is the check which corresponds to checking the same sequence number with itself. I mean, that is meaningless.
Diagonally match.
Exactly. So that is, this creates your left diagonal elements. We saw that the left diagonal elements were all 0 in our example. Right? All of these were 0. So this left diagonal element 0 thing that you are seeing, that is actually if I is not equal to J, right? Then only I am proceeding. I mean, the possibility that any of the entry can be 1 in this line could only happen when this condition is actually true, right? If it is not equal to J is happening. So that means if it is equal to J, it can never be 1. And that's why my left diagonal elements were implicitly 0. Okay. I mean, here we did not put 0 in any place, but we are assuming that initially all the values were 0. And whenever I have an edge, I would add 1 explicitly, right? So, okay, after that, what we are checking is if I not equal to J, but if, then I am checking whether there is a relation, whether the relation is bounding or not. So this check is nothing but checking whether edge can be there or not. Edge can be there between the current execution, right? Current execution is obviously this outer loop, so I and J would have the inner loop, so J would traverse through all the possible keys for a single value of I. So between I comma J. So checking whether an edge can be there between I comma J. So your I is the row and J is the column. So whether I and J. So if there, whether we can put 1 in this cell or not, that I am checking using this cell. Right? So if is related, now I am passing the entry, right? I comma j were the keys. Now in order to check the birthday and all those things, right, is related, I need to pass the whole data. So that's why I'm passing the value corresponding to that key, which is d of I and d of j. Right? You know that this is how we pass the value, right? So if I have a key, so d of key, this is how we represent the value. So this is nothing but the value for key. So I'm passing the values inside the isRelated method, and the x and y are storing these two values. And then we have already discussed this method what it is doing.
Yes, sir. Value is actually list.
Yeah. So now if it is true, that means there is the relation holds, and that means in terms of graph we would have an edge. And since the relation holds, and that means we have an edge, we, in order to represent this fact, we are putting 1 in the matrix at the place of I comma j. Okay, I told you in order to access a matrix, all you have to do is just put the index, the row index and the column index. So
Yes, sir. Yes, sir.
That's all. But to put whatever
Yes, sir.
value
Whole
you want.
code we have understood, sir.
Great. So this was the basic accessing of matrices and representation of a graph using matrix. Now we will go to some. Okay, by the way. So now once we have done that, let us see what was the main question. Which of the following statements are not true about the graph? Not true about the graph. There are at least 2 cliques in the graph.
So there is only one.
Is it?
So we just find out, right? Only one. Or
Sir,
we can say 1 or 1 also.
Sir, we have to join.
Oh, this is also 0, 1 also.
Yeah. So here we are actually considering. So that's what I was saying. Here we are considering that 0, 1, these two are same, right? Male, and that's why we are saying that this itself is a. I mean, although it's an edge directly, but in that sense it is forming a clique. As someone was telling, if there is a single edge, so we can consider it a clique or not.
Yeah.
So here we are considering that.
Okay.
Okay. In every clique, there is at least a pair of students having different date of birth. But this
No,
by
no,
definition
not true.
This
not
must be
true.
wrong. This must be
by
wrong.
definition, right? Right? Because what was the definition of an edge? The definition of an edge was that the birthdays should be same. I mean, the edge definition of that edge was if birthday and your
Gender.
Gender
are same.
must be same.
So unless and until I have these two properties same, I cannot have an edge. If I do not have an edge, I do not have the question of forming a clique. So obviously it's false. So this is wrong. All students in a given clique have the same gender by definition. All students in a given clique have the same date of birth by definition. So basically these three can be solved by definition. Only this part you needed to have an understanding of the graph. So again, one important point from your exam perspective. Once you see any graph problem, right, and let's say there is a table of data given, just see the options first. It might be the case you need not solve the whole question. Just by definition, you can see that, okay, these points are correct and these points are wrong. See, in order to answer the question, if let's say one option was not there or some other thing was there, you could have solved this question even without drawing the graph or making the matrix or anything. These three are solvable using definition.
Yes, sir.
So just see that.
Yes, sir. Actually, in statistics, when I was solving a question, I was calculating the value, but actually I need not to calculate value because options are easily eliminatable, sir.
Yeah.
So we always first see the options, sir.
Right. Solution is, we would release this document so you can see the worked out solution, but I think I have discussed all of the details. See that. Okay, but anyway, see the dictionary. See the dictionary is looking somewhat like this. As I have discussed, these would be the keys, right? All the keys would be here, and the value would be a list. Now, line by line, you can go through all of this. Okay, I did that Whatever I did, it's just line by line, same thing. Now you are getting solved. See the matrix that we draw. This one, and the symmetric last part. This is the clique. In the graph that we drew, 3 by 4, 0 and 1. Actually, I made one mistake. I mean, not I. In this graph, there is a mistake. In my graph, I think I did it correctly. Just check. Yeah, I did it correctly. See, very small mistake, but it is a mistake. When I'm
2 is not
drawing the-
mentioned.
Correct. 2 is not mentioned. Please mention these 2. Even if it is not connected, still it is a graph. So,
Sir, what you have said, I did not understood.
I'm telling just a minute. Oh, sorry. This is written cliques in the graph, not the graph. Okay, then it is fine.
Yes, cliques.
What I was saying is, let's say if I write this as the whole graph, right? So then it is wrong because I have not mentioned the 2 vertices over here.
Yes.
But it returns cliques. So cliques is fine. If it is cliques, then there are 2 cliques.
So actually here we are neglecting the isolated vertex. Isolated vertex is not a
That's not
clique.
a clique, right? Yeah, that's not a clique. Single vertex is not a clique. Okay, so these 2 problems I will discuss. I'll take a lot of time. See, again, same kind of concepts, but here I have now the data as one movie serial number, same thing, kind of serial number, and *1 and *2. Let's say this represents a movie data set, and *1 means the hero, right, or the, let's say, I think that term used is protagonist, and other one is the antagonist. So this is your protagonist, and this is your antagonist. So basically,
So
I'm
what is protagonist and antagonist?
just consider
So
hero and
nothing,
villain.
hero and villain, nothing else.
Yeah.
Okay, fine. So hero and villain, there are 2 stars and movie serial number. These are the movies, and then you can see that if I write, this is the movie dictionary, right? First of all, this is the table. In order to draw the graph, I am converting this movie table and representing in the form of a nested, not nested, a simple dictionary. We are representing in the form of a dictionary like we did earlier, and that dictionary is called the movies. Okay, this movies is a dictionary, and in this dictionary I would have the 0 is the index. Sorry, not index. 0 is the key, and corresponding to this key, I would have the numbers for *1, *2. Let's say 3 is the *1 and 1 is the *2. Okay, likewise, comma 1. Same thing. All the stars would be there.
So, sir, the values corresponding to this are not unique, right? So it can be repeated inside the matrix.
Correct. It can be repeated. Let's say the 5th movie is done by same stars 3 and 1. Okay, now we know the dictionary, and now we will go to the code over here. It should work with the graph. Okay, again same thing, 4 stars. Let's say now the graph name is, or the matrix name is 4 stars. Okay, create matrix n comma n. N is the number of the movies, right? Because you are creating it. Sorry, not the number of movies. When I'm going with n, the definition of n, where is that part of the simple?
Sir, it must be something like movie number 1 or movie 2. So name of the movie, instead of a name, we are representing with 0, 1, 2.
No, here it is actually, I mean, I think I forgot to write that, but basically let me write it over here. So here n equal to the number of, let me just write it like this, number of stars. Okay, stars means both considering protagonist, antagonist, hero, villain, whatever.
Actors.
Number of actors. Okay.
Sir, your audio is not coming.
Sorry.
Yes, now audible, sir.
Okay. So because now we are making this co-star matrix, okay, and let us say that I have the 0 star first one, second, let's say for smaller number 0, 1, 2, 4, and let's say I have a 0, 1, 2, 3, 4. Let's say 3. So this is my matrix. Okay. And 1 0 means what? Whether my first star is 1, second star is 0. 2, let's say 2 3 means what? First star is 2, second star is 3. But so I now have the matrix at this point, and rows and columns basically tell they represent the stars or the actors, right? So in this example I have 4 stars or 4 actors, 0 1 2 3. And in generalized code, this I have n stars, rare actors. Right. So now I have the matrices, but I still don't know about the relation. That is how to put an edge between those vertices. That I don't know. So that we will see now. So let's see for each I in keys of movie. So same thing. I now go through the movies list. Movies dictionary and go through all the movies that I have. The movies dictionary was something like this. 0 was the ID of the movie, and then let's say star 1, 3 or whatever.
Sir, can I ask you something?
Yeah.
Sir, in that code, you haven't mentioned like I should not be equal to J, right? There might be a certain case like double role, right?
Correct, but yeah, maybe.
So I think there should be mentioned, otherwise we can assume there could be a double role also.
Yeah, you can assume that. Since it's not there, you can assume that. Let us see. I forgot what options are there, but let us see. If there is some change, I would discuss.
Okay.
As of now, you can assume double role, because if it is not mentioned in the code I not equal to J, then obviously I can have IJ same. Okay. So let us see what happens. So for each I in keys of movies, okay, I go through all the movies. Star 1 is first of movie, so this is my hero and this is my villain. Okay, and then what I do is now 4 stars, star 1, star 2. Okay, equal to 4 stars, star 1, star 2 plus 1. So basically what I am doing in this line is, okay, I am adding whatever value was already there inside this cell, inside this cell of the matrix, right? 4 stars, star 1, star 2. Some value was already there, right? And in the initial stage, assume that the matrix are filled up with 0. Like, okay, just assume that. So in initial stage it is 0. Then after that, what I am doing is I am not replacing by 1. In the previous example, we were replacing by 1. So the previous example was a example when you were having that non-weighted kind of graph. Simple connection means you are putting 1. Either it is 1 or it is 0. But here we are doing addition and putting inside the matrix, right? So addition and putting inside the matrix.
But before addition, their value should be exist there, no?
Initially it is 0, right? That's what I'm saying. Assume that initially all values are 0. So when I am doing for the first time, this line of code is executed for the first time. This part would be 0. Initially assume everything was 0.
Whenever matrix created, already there 0 exists, right?
Correct. That's our assumption. Okay. That's our assumption, and that you will assume that in the programs, right? When you are actually writing in any programming language, right? So then this would not happen. But at least in this course, we are assuming that. Fine. So in your further courses, you would learn that if I do not assign any value to the matrix, right, then what problems we might face and all those things. But in CT, just assume that zeros would be there. So what I'm doing is now adding up the value. So this is not a unweighted graph, right? Because here I am, every time I'm adding up, this would actually give a proper positive integer, and that integer is placed inside this matrix as cell, right? So this would be a weighted kind of graph that we discussed. So co-stars initial value, this is our initial value of co-stars plus 1. Initial value was 0, so 0 plus 1 is 1. So let's say whatever entry it is, let's say this entry I am talking about 1 comma 2 is 1. Suppose. Okay. So after that, what I am doing? Co-stars of star 2, star 1. Or let's say if I do itself on the same data, right? It would be more than this. So what was the data? 3, 1. So this is 3, 1. So 3, 1, 3, 1. This one. So this would be 0 plus 1, which is 1. And then I'm doing co-stars of this 3, 1.
Now 1 comma 3.
1 comma 2. So 1 comma 3. Here also I'm adding. Likewise, this would continue. Let's say somewhere else again I had an entry. Let's say some value was there. Let's say some X movie ID where I had, let's say 1 comma 3. Okay, what would happen? 1 comma 3 would be added 1, so plus 1 would be there, so it would become 2. And obviously again 3 comma 1 because in both lines, because in that case it would get reversed, right? So this would become 1 comma 3 and this would become 3 comma 1. So in either way, both of these again would become 2. Okay. So now this becomes a weighted graph. So what I'm doing in these lines are actually, but what is getting statement in English? What's happening when this whole two actually terminates?
If a movie can get A and B, and the second movie can get B and A, so we are counted both.
Correct. So what can I say corresponding to the actors? Any information regarding the actors which is there inside the? So when I say the second actor, let's say this one. Let's say third actors, first actor's intersection value is 2. What does this mean?
That means they both do 2 movies together.
Correct. So the entries inside the matrix actually tells how many movies both of the participating actors did together. Right? That's the point. Now, does this value depend on the who was villain or who was hero?
No.
I mean, no, exactly. That does not depend on the who was villain or who was hero. So that is done. After that, let us now go to the, so now like this, if I proceed, the matrix would be filled up. Now let us see what this part of the code is doing. I mean, obviously, you all should be very familiar with this code now. I mean, these terms would be a little bit different, but you can understand what's happening. It's simply finding the maximum value in the matrix. So you check for I in J rows of co-stars. So this is your co-stars matrix, right? This is your co-stars matrix. So for I in rows and J in columns. So like you travel through a matrix, you do that. Okay. And if your co-stars of I J greater than max, so if the current value that I am getting is greater, then simply update the max with the current co-stars. So it is doing nothing but simply finding which
maximum number of the movie doing together.
Doing together. And whichever pair of stars did that together, I'm just putting that in the stars.
I think here I equal to J is not mentioned because someone can't be co-star for himself. So he needs someone else who can be co-star.
See, I mean, yeah, if you have a data set in the form, let's say both of them, I mean, as you said, in a double role kind of thing.
But co-star, they are saying the co-star means there is someone person who can be co-star with them.
So in that case, what would happen? These diagonal entry elements would not be zero. It would be some 2, 3, 4, whatever.
Something, yes.
Okay. So that would be there. So that's not a problem. I mean, since the code is not telling any restriction or not putting any restriction on the diagonal elements like previous. So in this case, even if I consider when I created this matrix, right, this line, this all the elements were zero. So these elements would also have been zero. But if I have an entry in the movie where both both antagonist and protagonist are the same person, like an entry of the form, let's say sub y colon 4, 4, so not 4, let's say 2, 2, right? In that
Yes.
case, 2, 2 would be what I would have is at first I would, so both of this would be 2, 2.
Yes.
Right. So for 2, 2, I would have addition 2 times addition. So I would have +1, +1. So this every iteration would actually give me 2 over.
Yeah, double counting.
It would be double counted. Okay. So yeah, so if it is asked in the question, just see the code, whatever the code is telling, just on the basis of that you can assume. Okay. It is nothing very particular, or what should I say, like compulsory logic. Whatever the code is telling, just follow. So again, the same explanation. What is max and star score? So what does max scores? Max scores does, we have said that
Number of movies doing together.
movies done together while some here. Maximum number.
Yes.
Okay, and star is basically the
Pair of
corresponding
the co-stars.
yeah. That's it. That's your answer. Very simple. Same thing. Solution is provided in detail. You can go through that and see what are the states of the matrix. Okay. I'm not going through in detail. See now see this is a weighted graph. That's we discussed all these things initially. So now if I see that 0, 1, so that means the, let's say, is just an arbitrary data. Like I took an arbitrary data. This is also an arbitrary data. So 0 and 1 actors, they have done together 4 movies. Okay, I don't know whether 1 was the villain in one movie or 0 was hero in another movie or whatever. But I know that performing together, 0 and 1 did 4 movies, 1 and 2 did 2 movies, and like this. Okay. By the way, from this graph, can you tell me whether 1 and 3, whether 1 and 3 did any movies or not?
Not from this graph.
Yeah, from this graph only I'm thinking. This is also just an example graph.
No. They didn't do any movie together.
Because I do not have an edge like this.
Yes.
Okay, great. So just go through all this. Next question. What we are doing in this? I would wait for the answer for this.
Maybe number of nodes, maximum number of nodes connected to other nodes.
Number of nodes connected to. Can you tell me in terms
Sorry,
of
a node connect. Okay. So the actor who has performed with other co-stars maximum, like let's say A has performed with B as well as with C, with D, like A is performing with many other co-stars.
This is the I, popular.
So if I write the code, what is this part doing? It is for every J I am counting for every ith star, counting number of distinct co-stars. Okay, so this part is doing that, and whenever I'm getting someone, I'm increasing the count. So count would actually store the different co-stars with which my ith star has worked. So this part is doing that, and I am repeating this step for all the different stars, and that's why every time I go for a new outer iteration, I initialize my count with 0. And after I complete this loop, this is actually up to this.
Maximum work experience, co-star.
Work experience. I would say that in that, yeah, the number of the star which has worked with maximum number of stars, other stars. So if you see after this loop ends, we are actually checking what is the maximum count till now.
And we are assigning that is co-star with popular
value. So that ith star is the popular one because many other stars are acted. So max would store what?
have worked together, sir.
Max would store the number of stars who acted with the star.
The co-star who have maximum number of connection with other co-star.
Yeah, who has maximum co-star. Okay, so the number of co-stars who acted
Can
with the
you
person.
explain once the max one, sir? I'm a little bit confused.
Yeah. So see, at first, what is count? Once we understand count, max is easy. What is count? Count
The
is
number of movies.
no. Count is not the number of movies. Count is, see, what we are doing is for each j in column of co-star, right? So what is the column of co-star? Co-star was this matrix where was this matrix, right? Where both the rows and columns were nothing but the stars, or both of them were stars, rows and columns, right? The matrix that we draw just above. So that was co-stars, and I comma j means the ith star and the jth star in the matrix. If I write, say, let's say I, and so here we have j. So this particular entry I comma j would actually mean that how many movies I and j did together.
But whether this is 1, 2, 3, 4, we increment only 1.
Yeah, whether it is 1, 2, 3, 4, I increment only 1 because in this code we are not counting that how many movies they did together. Rather, we are counting how many different stars has worked with a single star.
Oh.
Okay, so how many different actors acted with, considering a particular actor, how many other actors have acted with him? That's the thing that.
Sir, I understand that, but can you please show it like how it will traverse like in the matrix?
Sure.
Yeah.
Sure. Okay. So I got the answer very fast. That's why I skipped all of it anyway. So let us discuss.
Sir, because it is very much predictable. You know?
Actually, sir,
Okay.
actually, the pseudo code of matrix is mind blowing, sir.
Yeah. Okay. So fine. So for each I in rows, co-stars is this matrix, right? There's your co-stars matrix. I'm traveling on that. And what I'm doing is for each I in rows. What is rows? This part, right? So I is traveling. That's why I've written I over. So I is traveling in this direction. So what would be the first thing? So 0, 1, 2, 3, 4. Let's say there are 4 ones. 0, 1, 2. Let's say this j is corresponding to t in this case and 4. Okay, so this entry is 2, 3. Okay, so I am initializing count equal to 0, some variable count equal to 0, and let's say now I is initially, let's say I is, if I start from 0 itself, right, I is initially 0. Okay, count is 0. For j in columns of co-star, okay, again j also starts from 0 because column starts from 0, right? Both rows and columns start from 0. So this is my column. So this is also 0. So j is also 0. If co-star of ij is greater than 0. So obviously 0, 0, if both I and j, so that means what? The same posters, if that is greater than 0 or not. Now in the matrix, you have to check whether we have an entry corresponding to 0, 0. Now we know that in our code, at least we know that we did not had the condition where I not equal to j was there. So from the code, we can understand that, okay, if that is the case, if I comma j not equal to 0 was not there, then I can have some non-zero value for 0, 0 as well, where both, I mean, I would be counting twice, but I can have non-zero value. Okay, but then we are actually getting here an error. So that's what I said. We have to check. If I have this 0, 0 not equal to greater than 0 condition, and I make count one more, so that would mean then I acted with a different actor, but actually 0, 0 is not the case where I'm acting with a different actor. Okay, so from that point of view, again we have to modify the code. So it's better to actually add that condition I not equal to 0. Otherwise, we are getting into trouble in the next question. I would add that here. If your sorry, for which my in key is right, because I fine. Let us add this condition.
Yes.
Okay. Otherwise, this question is still fine, although a bit wacky or so because I'm counting twice. But the next question would be surely wrong. So let's add that condition that we are only considering for different actors. Fine. So now since I have done that, I am assured that all these values will be 0. Okay. Whatever. Just assume that the initial values are 0. This is 2, 3. So okay, this entry is not. Anyway, just assume the left diagonal elements are 0. So for if j is 0, obviously this I comma j greater than 0 would be false, right? So I would not come inside of it, and count is anyway 0. So I proceed to the next iteration. Sorry, not the next iteration. I proceed for 1 over here. Yeah.
So are we looking for distinct coactors?
Yeah, so since I have added that condition I not equal to, sorry, the star 1 not equal to star 2 in the main pseudocode, right? Where we are making the matrix. So that's why we are looking for distinct now. Okay. Fine. So now the next iteration is now 0 is done for 1 I am doing now, but I remains same because it is the outer loop. So okay, now for 1 let us see. So 0, 1, this entry I am talking about. Okay, so whether if posters of 0, 1 is greater than 0 or not. So if I have an entry for a movie where 0 and 1 actors have acted together, then I would have 0, this would be greater than 0, and I would increase my count by 1. So that means 0, I mean, I would have 1 has acted with 0. Suppose 1 has acted with 0. Then let's say 2 is also a coactor. Let's say 2 has not yet acted with 1. I'm sorry, with 0. So let's say 2 was 0, and let's say 1 here had 1. Let's say this was 1. Let's say 3 is also 0, but 4 has 1. 4 has
sorry to interrupt you, sir. One more thing I wanted to ask, like it is something like is it same like we are taking out the card of a movie, and then we have seen, okay, 0 and 1, the actors representing 0 and actor representing 1, they are working together. They have worked together in the certain movie. And then we have taken out another card. Is it something like that? Or we have just, because if it is not like that, then there might be a chances that 0 and 1, they might have done 3 movies or 4 movies also, like same actors.
Okay.
So in that case, that won't be 1, right? But if it is only 1 card, Then we can say like a movie card. Let's say some movie name ABC.
No,
In that,
how many movie not matter, count only one.
no, I'm asking like, is it something like a card? I have a card of a movie. Let's say the movie name is ABC. And then I am looking at the card and then there I have seen the actor 0 and actor 1, and then I'm putting a data. Is it something like that?
Yeah, see, when you are talking about the card thing, when is it actually happening? This is not happening in the pseudocode which is there on the screen now. That happened initially when you created the co-star matrix. So when
That's
I made, yeah,
Yes, actually, you are saying right. How many distinct actor are there? You are not counting how many total actor. You are counting distinct actor.
This okay. So even if it is repeated, I will not consider that. I have to like consider it like they have done movie together. But it doesn't matter how many they have done.
Yeah,
Yeah.
but this is evident from the code. That's what I'm saying. See, this is not something that you are, I'm telling or you are believing something like that. What I mean is this should be observable from the code. Now, let me just tell that when we created this co-star matrix, what did we do? That's why I said, does it matter that who acted as villain or who acted as hero? It did not matter, right? Because I was increasing both ways. Let's go to the code. Here, when I did this line, when I wrote this line, this is the place where I defined my co-star matrix. Okay, so in co-star matrix, I did for star 1, star 2, and as well as star 2, star 1, both ways. So that is fine. Now, even if we had multiple movies, let's say there are 4 movies which star 1 and star 2 did together, right? But in the co-star matrix, I would have only one entry where star 1 and star 2 would be there. I mean, 1, 2 and 2, 1, that symmetric thing would be there, but even if they have done 100 movies together, this value inside this would change, but only one entry would be there corresponding to star 1 and whatever star is, let's say these 2, star 1 and 2, only one entry would be there, right?
So we are not taking the magnitude of value, sir.
Yeah, we are not taking magnitude. Magnitude was taken while creating the co-stars matrix over there. So there can be 3, 4, whatever. Okay, anything can be there. But what
we are
I'm
actually
saying
not
is,
concerned about magnitude. We are only concerned that whether we have touched that cell or not.
why is it so? Yeah, correct. But why is it so? Let us come back to the code again. My point was, when I created the matrix, for every pair of actors, for every distinct pairs of actors, I would only have one element in the matrix. And that element would store the total number of movies they did together. Okay, irrespective of the number of movies they did, my entry in the matrix for that pair of actors would be only one. There would be only one entry. Now,
One
if
cell corresponding.
one cell, exactly. But now if let's come back to this code now.
So we are actually counting the cells, right?
Yeah, we are counting the cells. Why? Because see, here I'm traversing on posters. I'm traversing on the matrix, not on the dictionary. Previously, I was traversing on the dictionary. The dictionary had multiple movie rows. I mean, I can have movie M1, which was done by 1 and 3. I can have movie M6, which was done by 1 and 3, whatever. But when I created the matrix poster using this dictionary, in the matrix, I would only have 1 and 3 as one row. Sorry, one cell over here. 3 and 1. Right? This cell would be only one distinct cell. And the value inside this would be the number of movies they did. But here in this pseudocode, I am traversing on co-stars. That is this matrix. So if I am traversing on co-star, I would only get the pair corresponding to 1 and 3 once. And that's why I can say that it is because of the distinct. And that's why I can say that this count will store the distinct elements. I mean the count for distinct number of actors. Does that make sense? I mean, here I'm traversing on the matrix. That's why it would only happen once. Because I created the matrix in that. You can ask if it is not clear, if you are not 100% clear with it, please ask. Okay.
Sir, I'm not 100% clear.
Sure.
Yeah, me too. I'm still confused about the count.
Sir,
Okay, sure.
Could I try in one line, sir?
Okay, try. Okay.
Actually, how many times we are visiting a cell? If I ask a first question, how many times we are visiting a cell? Only one time we are visiting a cell in this pseudocode. And the second question is how much you are incrementing? You are incrementing 1. So the conclusion part is you are checking the cell. If there is something, then you are incrementing.
Suppose in two row, all cells are filled. That's mean this is the maximum time cells we are covering.
If there are 2 rows, you go to the first row. If all cells are filled, then you got count to be 5. If this is a matrix. So you are saying there are suppose you go to the first row, 0th row. So you are saying to 0 there are 5 people related. You are not saying that how many movies are related. You are saying 5 people are related.
So 0 is the person who acted with maximum number of co-stars.
Yeah.
Sir, actually, I understand what he said, but I am not getting like from where the data is coming. Like I understand like how the matrix will form and how we will find out. But the very basic thing I'm not getting is from where the data is coming. Like you said, the co-stars INJ, right? So
if
from
there
where?
is 0 in cell, if there is 0 in cell, you know that the cell is not touched.
Yes, it's not touched. So can we create a data at least like?
Yeah, that's what I'm doing.
Yeah.
So you said that you are not getting where the data is coming, right? So what's the how we made poster, that was clear, right? Or is there a problem in that?
From the dictionary, yes.
Okay, so we from the dictionary, but if I write, let's say here, I write, let's say 4. What does it tell you about, let's say I want to now ask you that what does this 4 indicate?
So this 4 indicates that the star 2 and star 3, they have done total 4 movies together.
Fine, great. So these 4 movies, who was the hero and who was the villain, I don't know.
Yeah, that doesn't matter actually.
Great. So now if I have this thing, so 2 and 3, so 3 and 2, let's say could also be 4.
So are we taking the matrix which we have created before as a base?
Yeah. Poster is that matrix.
Okay, so from that base, that's why that if whatever value it is, if it is some value like 3 for 0 to the 3 value is there. So if there is some value, we have to put value 1 there because there is some value. Right? That means they have done some movie. Oh, I got it now. I understood. Yes.
Yeah. So this posters is the same matrix over here.
Okay. Yeah.
So once we created that co-star matrix, now on that we are working. I mean, this pseudocode is working on the co-stars. Here we do not have the dictionary. In the previous example, we had that dictionary. On that dictionary, we were running the loop. So here we were running the loop on the dictionary in movies. Right? So this movies was the one on which our loop was working. And using that, we created the co-star matrix over here. And now using that, this was problem 2. And using that co-star matrix that we created, now we would do this third question. Okay. So 0, 2, and this should be 2, 0 should be fine. So if that is the case, and we are working on the co-star matrix that we already had created, and we know that every I, j entry in the co-star matrix means the number of movies I, j actors did together. Now that's our base. That's what we know as of now. Now if I proceed like this, what we are doing is for each I in rows, that is for every actor over here, right? In the rows are in this direction. Okay, so if I proceed in this direction, for every actor, so first I would do for 0, right? I will do for 0. So initially I am making count equal to 0 for each j in columns. J in columns. Okay, so columns is in this direction. So again from 0, 1, 2, 3, 4 I would proceed. Now I added the code if star 1 not equal to star j in the previous pseudocode. So if that is the scenario, all these diagonal elements would be 0. Right. Now obviously j equal to 0, this if statement would be false because this 0, 0 is true. I mean, sorry, 0, 0 is 0. So this is not greater than 0, and that's why it would be false. This would be 0, right? 0, 0. And that's why this if statement is not calculated, and I'm moving over here to the next iteration of 1. That was right. And again, I would repeat the same steps. Now this would be 0, 1. Fine. And I see whether 0, 1, 0 and 1 has done any movie or not. Let's say this is also 0. So again, I see that no, it's not greater than 0. So again, false. I move to the next iteration 2. Now I see for the second coactor, I see that 0, 2 is 3, right? So 0, 2 is 3, which is greater than 0, and that's why I increase my count by 1. So count was initially 0, right? First initialization was 0, and I'm adding 1, so it becomes. So likewise, let's assume that all of these are also 0. So that means this whole iteration would complete. This for loop would go through 0, 1, 2, then it would go to 3, then it would go to 4, and then it would terminate. So at the end over here, at this point, my count would store what? 1. For which? For I equal to 0. Because I is 0 in this case. And then I check whether count is greater than max. Let's assume max was initially initialized at 0. And popular was also 0. So popular equal to I is 0 in this case. So I am initializing with 0. Now I would go to the next outer loop, that is from 0 to 1. So I would do the same step for the first actor now. And I would check that where I am getting non-zero values within this row. That is with which actors one has acted together. Okay, so now let's assume this was 5. So 1, 3 is 5, 3, 1 must also be 5. Let's say this is also 2. 1, 2 is 2, so 2, 1 should be 2. And let's say this is 4. 1, 4 and 4, 1. Okay, so here what would happen? As I go through the steps again, and obviously since this time I am with the outer loop, second outer loop iteration, I have again initialized count to be 0. Because I am now counting for the first actor, I mean the actor with ID 1. Initially I counted for actor with ID 0, and I got my count to be 1. So which means because only one cell in the row for 0, this row, on only one cell I had a non-zero value. That means the actor 0 and actor 2 are the only pair of actors who acted together with that. I mean, 2 is the only actor who has acted with 0, and no other actor has acted with 0, and they did together 3 movies. Okay, so the number of unique actors who acted with 0 is only 1, which is 2. Accordingly, when I proceed through the steps for this row, I would get the number of unique actors who acted with actor 1 is 3.
3.
Right? So I would proceed through these 2 lines and I would get that. And then when my count is 3 for I equal to 1, then count is max was 0 initially. Count is, sorry, not max was 0, max was 1. Right? Because 1 was the
1, sir.
Yeah. So count is 3 now. So 3 is greater than 1. So that's why I initialize my max to be 3. And my popular becomes what? It would not be 0 anymore, it would be 1. Because 1 has acted with now 3 different actors.
Sir, can I ask you another question?
Yeah.
Sir, I understand this. I don't have any problem, but I have a problem in the code. I want to understand like from here, like for each J column co-stars, we usually do like J++ or I++ to traverse, right?
Yeah.
But why we are not doing it here? Are we assuming it like if it's a matrix and for every column J, it will traverse like for each, okay, for each J means we are considering it is included.
Yeah. Here we, I mean, see, when you're writing in a programming language and specifically, let's say in C++, then we do that I++ or J++. But here we are assuming.
For each, we don't need this increment. It will
yeah,
by default.
Yeah.
Okay, so we are considering it as it is a pseudocode.
This is pseudocode. Yeah. Since you're writing columns of co-star, so basically this columns of co-star that would give you the result as all a list, and that list would be 0, 1, 2, ... 4. Okay, and then you are writing for each J in this list. So that means basically you would go through all the single elements in this list. That's what we are.
And increment operator is used in while loop.
See, actually, in Python, when you write code in Python later, you would see that this kind of syntax you can use very nicely every time. But if you write code in C++, then you cannot do something like this. There are some. I don't want to say all those things as of now. There are STL libraries where you can use for each and all that. But basic C++ coding uses I++, C++. You have to traverse through them. But in Python, you would see this kind of format very common, and that's what you would be learning next. So that's more relative. Okay. So, yeah.
Yes, sir.
as
Our
of
first
here yeah.
programming language is Python, sir. That's why this type of pseudocode we are learning.
Correct. So that's why we are learning. We are proceeding it in this. One important point before ending. So there are other two problems as well, but those are not very difficult. I mean, they don't have pseudocode. You can just go through them. It's more diagrammatic. This is the solution part of this, which I already discussed. The second one has only diagrams. Little bit pseudocode is there. You can check that. But before that, I want to discuss one important. And that's what you would face in your next week actually. Yeah, so here, observe the code.
And sir, for 11th week, one more request. On 20th, there is quiz 2. And on 25th, there is deadline for week 11, sir. Many people travel very long distance, about 100 to 200 kilometers for the quiz exam. So 2 to 3 days actually gone. So please extend the date of the week 11, sir. 28, at least 2 days, sir.
Okay, I will see.
Because at 20 it is exam, so we get time after 21st, 22, 23, 24, sir.
Okay, noted. I would ask.
Yes, sir. 2 days, sir. For week 11, sir.
Sure, noted. 2 days. Yeah, so the point that I wanted to discuss here is, see, one important thing is when I told you how to access matrices, we discussed that you can write, let's say, in the matrix, I would put some, let's say, some value over here, R or IJ, whatever, and the first one is for row, the second one is for column. Now for matrices, right? Now please be careful here. For matrix, there is one compulsory condition. Okay, R and C should be positive integers, so they can be only 0, 1, 2, 3, 4, dot, dot, dot.
So positive integer wise, sir. 0 is not positive.
Yeah, you can consider that. In computer science,
Yes,
you can say natural number, whole number, those things are there. So just consider that fact. What I mean 0, 1, 2, 3, 4, you can have those things. The thing is, see, did you observe all the example, and not all, we did only 2 main data sets, but you see that here serial number was 0, 1, 2, 3, 4. In the previous case also, our series sequence number was 0, 1, 2, 3. What happens if this is not 0, 1, 2, 3, 4, this is some serial number like S001, S002, whatever, S00 and something like this. So what happens to our pseudocode? I cannot write RC, right? Here we were directly able to write this sequence number or the movie number. Okay, I can write directly the movies or stars or whatever. In fact, you see the stars. In the matrix, we were writing stars. What are these stars? These stars were numbers, isn't it? 3.
Yes, sir. It was numbers, sir.
What if it was, let's say, Tom Cruise, or let's say here Ajay Devgan, so whatever, right? So like this, some names are there. So then, can't we have matrices? Can't we represent the same using matrix?
I think we have to represent Tom by some positive integer.
Yeah. See, exactly. So what we have to do is, only thing we cannot write statements like this, *1, *2, because first of movies would be Tom and this would be Ajay. So we cannot do that.
So
Right?
I
We
think
cannot.
first we have to create a list, a dictionary with key as a Tom and Ajay and value as a number.
Exactly. This is what we need to do. Okay. And dot 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 whatever, we would have a key value pair like this. And then when I'm writing star of 1, in place of star of 1, let's say this is called M or mapping. So what I would write, M of star of 1.
M of Tom, sir.
M of Tom, sorry. I mean, Tom would be star of 1, right? This star
Yes,
1.
sir. Yes, sir.
So M of star 1. And then inside this, I would write this. Fine. So I just mentioned this because most of your codes in the next week would be like this. And you would use an index to operate upon.
Initially, computational thinking was easy, but as later on, it become difficult, sir.
When you go to the PGSA course, you would see what is difficulty. So it's fine. Just understand the basic concepts properly.
Yes, without computational thinking, I don't think such thing is easily.
Sir, this thing is not much clear that you're saying that the number to Tom 0, Ajay 1, that's like if for each and every actor we have assigning some numbers.
Yeah. So because in matrices, I told na that when you are operating on matrices like this condition should be true, that every time it should be an integer. That's the
Yeah, that's I got it.
so
Then if there are 10 stars, then 10 stars we have to first assign for 10 star as 0 to 9 numbers. Then we will do this kind of thing.
We can create a procedure for, I think, that.
just simply make a loop for each loop, make a for each loop for I in whatever your key is.
All co-stars.
Yeah, all co-stars, and then inside that have a dictionary called M, and then M of I plus plus or your M of I equal to what I mean is something like this. You can just write this time. For each J in keys of whatever dictionary you have D. Okay, so if this J means the name, right? Ajay, Tom, or whatever, that would be there. So create an M. You can also make a list as well. So no, not list.
And sir, this matrix you have said a positive integer means it is starting always start from 0, sir, right?
Yeah. Like this, and let's say outside this for each loop, you created I equal to 0.
Yes,
So
yes.
This is what you have to do. That's
yeah, now I get it.
Fine. Okay. So that's it. Thank you all for joining the session.
Thank you, sir.
Okay. Great. Good night.
Thank
Thank
you,
you
sir.
very
And
much,
sir, PDF
sir.
will be provided, sir.
Sorry, which one? What?
Sir, this PDF you will give, sir.
Yeah. Anyway, all these videos are released, right? I think in the supplementary contents it should be there.
Okay, sir. Thank you so much, sir. You have explained well, sir.
Thanks.
A 2-hour was for question solving, but you have explained, sir.
And now it's really
you, sir.
clear, far clear, because everything is so much. I was so clouded with all these thoughts, but now it's really clear for me. Thank you.
Sure, no problem. Thanks.
Okay, sir. Good night, sir.
Good night.
Thank you so much, sir. Good night.
Good night.